Might help if I unmute and probably be a better presentation. Good morning, everybody. I hope everyone had a good afternoon and evening yesterday. Yesterday, we were looking at how you would be using FireMon's various tools from an end user point of view and what you can do in Security Manager with all the data that you got from your lovely data collectors that were picked up by your firewalls. Today, we're going to get into how you actually go about administering FireMon in case that's something that you are tasked with. And we'll also go over how to use some of the additional modules that we haven't yet looked at. Specifically, that would be Policy Optimizer, Policy Planner, and Risk Analyzer. We're going to start off today with an overview of your administration panel features in FireMon, how you go about managing licensing, defining users and permissions, and also how you go about configuring device groups, and a quick revisit of scheduling automated reports, since it's a function that people tend to use quite often. All right, FireMon is going to be licensed by application, and that's application modules on our end, as in Security Manager, Policy Optimizer, Policy Planner, and Risk Analyzer. That would be a license for each of those application modules. Again, Security Manager by default, you will always have a license for that when you purchase anything FireMon related. So you can optionally purchase any of the other three. In turn, each of those modules is going to be licensed based on the type of number of devices that you're going to be managing with your ecosystem. For example, if you wish to manage 100 firewalls that have one management station through Security Manager, you would require licenses for each of those 100 firewalls and a license for that management station as well. Excuse me. You will generally be downloading licenses and any other associated files from our user center. You will need to download a new license under the following scenarios. The IP addresses of your application servers is contained in the license string that you're going to be given. Therefore, should that IP address of your application server change for some reason, you would need to update your license accordingly. If you are a managed security services licensed user, and you've added a new customer / domain, you would also need to license that additional customer and domain. When you add a new device type, for example, if you've only been managing firewalls up to now, but wish to pull in your layer 3 devices and manage some routers as well, you would need to license each of those devices as a different device type. And of course, if you've exceeded the number of devices in a given category for which you're licensed, you would also need to get new licensing for that. You can, of course, unlicense some of the devices that you might not be using and shift them around. Just be aware that you will lose usage data once you unlicense those other devices. If you ultimately want to add one of the applications to your FireMon ecosystem, as in Policy Planner, Optimizer, or Risk Analyzer, you would also need to license that additional application. And of course, you can always contact your customer success manager or sales engineer that you're working with to request a new license for any of those scenarios, and they would loop in sales to ensure you get what you need. All right, when we talk about permissions in FireMon, everything is going to be set at the user group level. If you create a user, that user is going to inherit the permissions of the user group to which you assign it. So individual users outside of a user group have 0 permissions. So if they're not assigned to a group, they do not have permission to do anything in your FireMon ecosystem. Note that those user permissions are also cumulative. So if you assign a user to multiple user groups, they will effectively inherit the permissions from all of the groups to whom they're assigned. Users and user groups are set up under the Access tab in your administration panel. We'll be taking a look at that shortly. That's also where we would set up a user's authentication method when we create them. If we wish to authenticate a user off-board, quite possible, and we'll get into that as well. User groups are also how you're going to restrict access to applications and features within your FireMon tools. We follow the least permissions model, so unless you've been explicitly granted permissions through assignment to a user group to a particular module or function, you will not have any such permission. Or we'll be looking at a number of permissions within the tool shortly. There are quite a few that can be set just for the administrators. For example, they could be given permissions on what event logs they could view, whether or not they may make changes to settings on data collectors, if they can upload new licenses, and a whole bunch more. You can get extremely granular in the assigned permissions. Let's say that you have a team, for example, that only creates users and manages users in your FireMon ecosystem. Since you have a very large footprint, you would obviously not want to hire extremely technical and expensive people to perform that task, but you also wouldn't want them running amok all over your beautiful FireMon system. So you could actually just assign them these user and user group permissions right here, which would allow them only permissions to create and edit user groups in your FireMon ecosystem and do nothing else. All right, when we're talking at the GUI level, or graphical user interface, users have several options for authentication. They can be authenticated locally through the Security Intelligence Platform, or SIP, where that account's going to exist within the tool itself and reside in the database. You can also authenticate your users through specific group mappings on your LDAP servers. We also have support for Radius. However, in that case, the user needs to have a local user in FireMon first created to match up with their Radius account. We also support Active Directory and SAML. We can integrate with pretty much any SAML provider these days. We have customers using the most common ones, ADFS, Azure, Okta, which is actually the one we use here at FireMon, Ping Identity, and Symantec. Regardless of the provider you're using, SAML is going to generally be configured in very similar ways. However, as always, if you're having any issues configuring that, by all means, open a support ticket or reach out to your security engineer or a technical account manager, and they can help you get that set up in your environment. All right, having talked about that at a high level, let's just jump into the admin console and show you some of this in real time so you can understand a little better. Right. When you're talking users or permissions here, it's going to happen here under the Access tab in the Administration Center. This is where you're going to go to create new users or anything of that sort. So, for example, if you wanted to create a user, you simply hit the Create button here, give your username, your user a name. Notice that, again, anything with a red asterisk must be filled out in order for this to be saved. And then you can select what type of authentication this user is going to be subject to. If it's local, you would simply enter the password here in the new password field and then confirm it in the re-enter. And then you would assign this user to whatever user group you want them to inherit the permissions from. And this is where we really start getting into being able to manage what it is this user can and cannot do. So we'll shift over to the User Groups tab to show you some of those permissions. By default, in Security Manager, there is no default super user group that's going to be created. There will be no ability to do that for anybody. So the first thing that you have to do is use the default account that was excuse me, provided when your system was built, which is typically the FireMon user account. You would log in with that group and create that administrator group by using a template, which happens right here in the User Group tab. You would select Create from Template, and you would select this administrator template to grant other users the permissions that that super user has, the default one that gets created. And you could give that group whatever name you like and go ahead and save it and edit it. And then you will be able to see under the User Group Permissions tab all of the permissions that are going to be available to grant to this particular user group, which then you can assign users to. So here on the System tab, you will be able to grant permissions to play around with domains if you're a managed security services provider, as in multiple customer domains, as well as the plugins that are going to drive some of the device packs that will interface with your devices. Here on the Administration tab is where you will set most of the permissions for administering your FireMon ecosystem. You can see here that you will be able to grant permissions to view event logs, modify data collectors, licensing, assessments and controls. If you want to assign compliance purposes or roles to particular users, whether or not the users configure authentication servers, and so on down the line. There's quite a few permissions that you can set at a very granular level. Flipping over to the FireMon Objects tab here, this is where you'll be able to grant permissions that are going to be used in those compliance checks that we were just looking at the end of the day yesterday. You can see here that you will be able to read and write services and groups, compliance zones, and network segments that will be assigned to those compliance zones as well if you are assigned to this particular user group. Here in the Application Permissions tab, you're going to govern which of the FireMon suite of applications can be accessed by this particular group. Again, this is where you need to fix permissions. If a user that you've created tells you they get an authorization error message when trying to access a particular application in your FireMon ecosystem, For example, here's the administration center that I'm in right now, so that's why I am able to access and view this administration center, and I can select whether or not this particular user group would be allowed to use Security Manager, Policy Planner, Policy Optimizer, or Risk Analyzer. In order to view any devices, a user group needs permission to see the device group to which a particular device belongs. That access would be granted here in the Device Group tab. You need read access to view your devices, write access to make changes to those device groups, and then the risk permissions are required if you need to upload risk data for those device groups if you're connecting to some form of vulnerability management service in the context of the Risk Analyzer application. This is a fairly common problem area that our customers tend to run into. If you add a user and they come back to tell you that they can't see the devices they expect to see, it's likely because the user group they belong to lacks the permissions on that device group, which is also an important note for you that whenever you create a new device group, you need to come back in here and grant the various user groups the required access to that new device group so they can actually see the devices in it. If you are consumers of our Policy Planner or Policy Optimizer applications, which we'll be looking at shortly, those applications use workflows that drive how the tickets from them get created, and those workflows have specific stages in them. And here in the Workflow tab is where we can set very, very granular permissions for each of those specific stages, allowing an extreme degree of detail in who can see or change workflow-related items such as your Policy Planner change tickets or your Policy Optimizer review tickets. You can see that there's permissions for each stage of one of those tickets that you're able to set for this particular user group. Next up in the administration panel, when we're talking about users, is the Authentication Server tab. And this is where you're going to go to create authentication servers in order to authenticate your users outside of FireMon if you don't wish to use our hard-coded passwords in the database. By default, there are no authentication servers configured as they will be custom, obviously, to everybody's environment. You can just go ahead and can, for example, create an Active Directory user or a server here if you wish, and we could do that. Select what type it would you want to create, which should be Active Directory in this case. Keep in mind that if you're setting up Active Directory or LDAP authentication, you will need to get a copy of the certificate from that server and upload it to the application server for that to work. The documentation on how to do that is always available in the admin user guide. However, this is also a step that often gets missed or people find it a little bit difficult. So if you're having any problems setting that up, by all means, talk to your sales engineer or open up a support ticket with our team, and someone will come in and help you to get that set up. And finally, down here in the Access tab, we have the License tab, where you'll probably be going often to see what's going on with your licensing. This is where you come to upload any new licenses or modified licenses that you've been provided. This is also going to be populated, as you can see here, with all of your current license information. For example, we mentioned that that IP address of the application server is within the license string that you are licensed with, and that's it up here in the licensed addresses. If you have more than one application server, you may see more than one IP address here, and if any of them change, you would need to update that for your license to remain valid. This is also going to be populated, as you can see, with all of your current license info. Here's the number of firewalls that you're licensed for is 40 in my case, and I'm using 13 of those licenses, have 27 less, and so on down the line for all of the various device types that I might want to manage with my FireMon ecosystem. And you can see here that I'm also licensed to use Risk Analyzer. All right, adding devices is probably one of the tasks you're going to spend a lot of time doing day to day if you're a consumer of our FireMon product. In order to monitor devices, you must first configure them to allow connections from our data collector. For instance, if you want to monitor an ASA, that ASA will have to permit SSH traffic from the IP address of that data collector. If you're on Checkpoint, you would need to set up the management station to be connecting to the data collector IP address over the CPMI ports from Checkpoint. Non-Checkpoint devices will need a data collector system account created on that device. The requirements for that are going to be in the Getting Started guide. Excuse me just one second, I got a little bit of a hoarse throat. There we go. The requirements for setting that up are going to be in our Getting Started guide available in the User Center, and of course, those requirements are going to vary according to the type of device you wish to add into your FireMon ecosystem. Once the data collector gets set up to access the device and download its configuration, that device also must be configured to forward its logs to the same data collector. For non-checkpoint devices, that means you're going to be forwarding syslog data. That syslog data can come from the device itself, or it can come from some form of central syslog server, such as Splunk or ArcSight, or whatever type of syslog server you've got running in your environment. We can pull the logs from that, identify the device that they belong to, and use that to collect usage and change data. We just simply need to configure that device in our administration panel, and then configure the data collector to know where the traffic is going to be coming from. Once all that gets set up on the device or on the firewall side, then we can go into the administration panel, get that device added. Let's take a look at how we do that. So adding devices is going to be done here in that administration panel that we were discussing. If we wish to add a standalone device, it's not terribly complicated. You come over to the Create section here, and this is where you will be able to add whatever type of device you might be wanting to manage with your FireMon ecosystem. For example, if we wanted to add a Cisco ASA type firewall, we'd simply click the Create button, choose Cisco, and choose that ASA from the dropdown, and then we'll see the fields that we need to populate in order to add a new firewall in here. The device name here doesn't have to be the actual name of the firewall. It's just a logical reference in FireMon. Best practice sort of dictates that you would use the actual host names to keep everything synced up with your actual device configurations. The management IP address here is going to specify the IP address that the data collectors are going to talk to. So that means that if you're using NAT, you must use a NAT IP here so that the data collector can actually talk to your device. In the data collector group field here, it is where you're going to specify which data collectors are going to be talking to this device, downloading its configurations, and monitoring it for any changes or usage. Note that only one data collector can monitor a given device. So if you wish to use a specific data collector or data collector group for this device, this is where you would assign it. For anything that is collecting syslog data, you may need to assign a central syslog server. For example, if you were pulling the syslog data from your Splunk server, you would use the IP address of that central syslog server there, and use the central the syslog match name, which is what FireMon is going to use to match incoming syslog traffic to this particular device. And of course, that syslog match name will vary according to the device type that you're trying to bring in. For example, in the Cisco case, which is what we're looking at here, it would be the device IP address if we needed to set up a central syslog server. If you were using Fortinet, it would be the hardware serial number that you would match on there to be able to differentiate traffic between devices when using that central syslog server. If you have multiple match names to configure in strange syslog format that might be coming in, for example, ArcSight tends to be a little odd, you could configure multiple match names here in the external ID field for the traffic to be matched up to a device. Here in the device settings is where you're going to add all of the user information, i.e. the username and password that's going to be used to actually allow the data collectors to log into the device to collect its configuration. In this case, we're adding an ASA, so the fields here are going to show you some Cisco type stuff. You can see here that I'm going to enter your default username, the default password for the initial level, and if I'm using a different username for enable, I would have to specify a different username here. However, if the username for enable and the default username is the same, you simply leave the enable username blank and put in the enable password twice so that they can get in there. Right here in retrieval is where you're going to select which protocols you're actually going to connect your devices with. And since, again, this is an ASA, we're going to leave this as SSH. So we'll be connecting over port 22 from our data collectors to this ASA device to collect its configuration and monitor its logs, which also should tell you that you need to open port 22 between your devices and the data collectors that are going to be collecting their information. If we're doing any type of policy automation, we could enter the credentials here that will actually be used to push changes to the firewalls. If Policy Planner is being used, we can set those up right here. Under the log monitoring section is where we can toggle monitoring on or off to choose whether we track usage also by hit counter or syslog. It's set by default to count via hit counters. However, we'd probably prefer getting syslog. You can set it that way optionally, which is going to be the preferred method whenever possible, since you'll get more granularity on the usage. If you're tracking by hit count, it's going to show you what rules have been used. Whereas if you're tracking your usage by syslog, you will also find out the usage on the objects within those rules, so you can get a little bit more granular information from that as well. That also means that if we don't track usage via syslog, you would not be able to use such features as the traffic flow analysis that we looked at yesterday on this ASA. Here in the change monitoring section is where we can toggle change monitoring on or off. If it's on, that means FireMon is going to be listening for syslog messages that tell us a change has occurred on this device, and then it'll actually retrieve a new configuration to find out what changed. We can also set up this scheduled retrieval here to come in behind and a start time for which that scheduled retrieval will take place. It's very good practice to have both of these enabled. Keep in mind that syslog is in fact UDP, so it is connectionless, and it's always possible that a message indicating that a change took place on one of your devices gets dropped somewhere in your network before reaching the data collector. So having that retrieval run every 24 hours, which is the default at 1440 minutes here, is a good backup to have to make sure that you don't miss any configuration changes. A lot of devices are going to have some kind of advanced settings as well, depending on the device type. One that's very handy in the case of Cisco firewalls here is being able to click this little radio button here, the auto update SSH key option. If you ever get a retrieval error stating there's an SSH key mismatch between what your data collector has and your devices, or that the key needs to be updated, you could simply come in the device configuration section here, check that little radio button, and that'll tell the data collectors that should there be a key mismatch between the device and FireMon, it'll just go ahead, update the key, and continue with the retrieval, keeping you nice and happy. You can also select this skip route normalization radio button here. If you're, for example, adding in some distribution router to your ecosystem that would have tens of thousands of routes to collect every time it comes in, this is where you could tell FireMon to skip that type of download to avoid bogging down your system with multiple route pulls. This share the device section is only applicable if you are licensed as a managed security services provider and have multiple customer domains. You will be allowed to share this device in particular across multiple domains, which is generally not advisable from a security perspective, although in my previous life, living at an MSSP, this would have been useful given we used to have a large amount of checkpoint firewalls that had CMAs with global rules that we used for support access on our teams. Our server guys would have a global set of rules that we pushed out to all our checkpoint firewalls, and then they would automatically get access to any new servers that were added. That's about the only use case I could see for sharing the device across customer domains. Here in the enforcement window, this is where you can set the enforcement window for changes on this device, which is what's going to tell our policy planner application when to actually push any firewall changes that you created to those devices, and how. If you set that enforcement to continuous, that means that changes are going to be pushed out to the device as soon as they get approved in your policy planner application. You can also set push during a device change window, which you can set up here in the scheduled portion. Which will wait for that schedule to come along and then actually push the changes out. And the device change windows, the big one is what you will set up as part of your compliance monitoring that we looked at yesterday, that will allow you to actually trigger a compliance control in the event somebody pushes a change to one of your devices outside of your configured window. And finally, there's manual only, where changes will not be pushed to any devices until you actually go into your management station and go ahead and push them. Policy Planner will simply stage them for you and wait for you to manually put them in. We also have a supplemental routes tab here, which would allow you to add routing to supplement the routing tables retrieved out of your devices in order to fill in data that might not get supplied during the normalization process and help connect your devices in your network map, as well as enhance the accuracy of our access path analysis and rule recommendation features. You have to have normalized the configuration of the device before you can add any supplemental routes, which is why you see it as grayed out here. But once you've done that, you would be able to basically select an interface and specify the destination IP you would like to route to, and then choose the gateway for related traffic and set up that static route. That's basically the big difference between using supplemental routes and pulling in your layer 3 devices. The supplemental routes are going to be static, and therefore you must stay on top of them, manage them. You will not be able to leverage any kind of dynamic routing protocol that you would be able to do if you pulled in your layer 3 devices. Then FireMon would pull that routing information from your devices directly, as opposed to having static ones configured. The device pack section down here is one that you're not likely to use that much, as any related actions are likely to be taken in our device packs page. With that said, we can get some general information here, such as the device name and the currently associated device pack with this device type. Device pack, by the way, we haven't really discussed. That's essentially the script that FireMon uses to run the various commands for a particular type of device in order to collect its raw configuration, pull it in, and normalize it. All right, next up, let's take a look at how we would go about creating management stations if you need to do that. If you have devices that are managed by a management station as opposed to directly managed by your FireMon ecosystem, which would be the case oftentimes for Checkpoint or Fortinet firewalls, you would need to create an associated management station for FireMon to be able to talk to. So we could create those here on the management station page in the device section. In order to create a new one, again, pretty simple, click create, select what type of management station you want to create. If you are creating a management station for your cloud infrastructure, for example, AWS or Azure, your subscription will be treated as the management station ID, so you would create it through there. And once again here, let's just choose Checkpoint to demonstrate, and we'll do an R80 CMA. And just to show you that you'll be presented with all the fields here that you need to populate depending on the device type. And once that's completed, the data collector will start to retrieve the configuration of the management station itself, and will then attempt to retrieve the configurations of all devices under that management station through that management station, as opposed to talking directly to them. So I'll just show you one of the already existing ones. If you've created a new management station and along with the general device settings, that object will also have a discovered devices tab here. And that's where you're going to see the devices that are managed by that management station. If everything is set up properly, you'll be able to see what this management station is managing for you. And this is where FireMon will pull all of the information for those managed devices. So if you should retrieve the configuration of your management station, but don't see anything in the discovered devices section, or don't even see a discovered devices section, you can take a quick look, because it's most likely going to be an issue with the user ID that was created to use that, that was used to create that management station, and not having been granted the permissions on the devices that it was discovering. So that's a fairly common scenario with Checkpoint management stations that you might want to keep an eye out for. Make sure you assign those permissions for the devices under the management station as well as the management station. So if you're using devices that are discovered through a management station, by default in FireMon, the data collector is going to attempt to perform any retrievals and change monitoring for those devices through their management station. That behavior can be changed on individual devices if you wish. However, you're generally going to leave that in default configuration. It's a very specific use case to split out different devices off the management station. I have seen one customer who had a PCI environment, and they had different credentials set up for those devices that were protecting that. So they had those outside of their management station, and they used FireMon to manage those directly at a different security level. All right, that pretty much covers our devices and management station. The next tab that we're going to look at now is device groups. And this is where you're going to get to organize your devices in the groups that make sense to your particular organization, and is also what creates the structure of the navigation menu that we were looking at yesterday in your security manager application. So just as a quick reminder there, I'll switch over to security manager, just to give you a quick reminder of what that looked like. So you'll notice here that you will have that navigation arrow here showing you the various ways in which your devices are divided. And if they look familiar, it's because they match up with your device group configuration, which is exactly how they get configured. So if you need to create a new device group, you can go ahead and create it here. Just simply give the device group a name and then choose which devices you would like to be part of that device group. Device groups can be nested. You can put more than one, you can put a device in more than one group, and you can also nest device groups underneath each other. So you can pretty much group your devices any way you wish. You might want to do it by geographical information. For example, if you have global firewalls, you might want to have device groups for your Europe, your North America, your Asia Pacific, and so on. You might want to group them by function. For example, if you had PCI compliance requirements, you would group your PCI in-scope firewalls in a PCI firewall group that would allow you to perform any kind of PCI monitoring against them just by simply using that particular group. Pretty much up to you how you want to organize them. It is completely flexible, and it's going to provide you with a lot of abilities in how you view your ecosystem. Here on the device packs page is where we're going to view which device pack is installed for which type of device we wish to manage with our FireMon suite. Device packs, again, are essentially the scripts that are going to run against your specific device types, and they're going to run all the commands required to collect the configuration of that particular type of firewall. For example, if we were looking at an ASA, the device pack is going to run things like show interface, show running config, and other ASA commands in order to collect all of the current raw configuration from those devices, which will then be normalized by Security Manager and saved in the database. So device packs also are going to be updated with every new release of our software. However, there might be instances where you need to upload a new device pack or a different device pack than the one that's currently running on your devices in the context of a support case. Should one of our support engineers recommend that you update your device pack, they would provide you with a file which you would simply download and use here to upload, choose that file, and bring it into your application server and use that new device pack to manage that particular device type. Excuse me. If you have clustered devices, you can define them here on the clusters tab of the device page. Again, if you wanted to create one, you simply would give that cluster a name and assign which devices are going to be part of that cluster from the list of devices that you have down here. So I can give you a quick look here at this checkpoint cluster, for example. You'll see that there are two devices assigned to it, temp checkpoint 1 and temp checkpoint 2, and temp checkpoint 1 is the active one. There's always going to be one active and one waiting in the background. Here on the normalization status page, you'll be provided with an overall view of the normalization status of your devices. Remember, normalization is the process by which FireMon takes that raw configuration and massages it into that vendor agnostic view that everybody is after. This will show you a status, current status of all your devices. So if you're having any issues with normalization, this is where you would come to see what might be going on. And here in the collections configuration page is where you will actually get to take a peek at the patterns that are used to collect the usage and change data for each of your various device types. Generally something that you're not going to modify unless you're doing so with the guidance of our support engineer or your technical account manager under the context of support issue. But if you are curious, you can just open up the default configuration here and see the regex patterns that are going to be used to collect, in this case, change data or usage data from a given type of firewall that it's associated with. For syslog-based firewalls, everything is going to need to have some sort of syslog server defined. That's true even if the firewall itself is the log source that's going to be treated as the central syslog server and pull in all of the log information for that particular device. They're fairly straightforward to create. You just jump into here in the administration tab in system and central syslog servers. And if you wish to create a new one, you simply hit the create button, give that central syslog server a name, and then select the match properties here, which is going to be, essentially the match properties will be how we use those regex patterns to collect that usage and change information from that particular device. So by default, you'll have one here in the central syslog server configuration that can show you that one. And your default will be the list of match properties that are used for each device type. This is the regex pattern that is going to identify that is a Cisco, and then it'll go down further in the stack and start looking at whether it was a change or usage packet, and then either pull a new configuration or update the usage on your device. These expressions are typically going to show up inside one of those device packs. They can be modified if so required if you have an unusual syslog format, or if you've been instructed to do so by one of our support engineers under the guise of a trouble ticket. All right, FireMon currently has support for a large number of devices or types of devices, of course, including the big five: Cisco, Checkpoint, Juniper, Fortinet, and Palo Alto. We have some 20 other supported vendors and growing, currently with over 70 different device types that we support right now. This includes major cloud providers, Azure, AWS, and Google. You can always find the list of the devices that are supported currently by FireMon in the latest administration guide in our user center. That list is constantly being changed as we add new stuff. So there's always things being added in there. If you don't see the device type that you want to add anywhere on that list, by all means, contact your sales engineer or customer success manager who can tell you if it's in our roadmap in order to be supported in the future version, or help you submit one of those requests for enhancement tickets or RFEs to have it supported in a future release. All right, when we're talking about devices, you're often going to hear the term levels of support. That's the functionality that each device type can achieve within your FireMon ecosystem. There are 4 levels of support plus automation, which I guess would mean there's really 5 levels of support. Level 1 support is the most basic functionality of Security Manager, wherein we can only support raw text-based configuration retrieval without making any changes or modifications to it. There are very few devices I can think of where that's the only level of support we offer. Moving up the stack, we'd have level 2 support, which will encompass everything at level 1 for the raw configuration pull. Only now we're adding in that normalization of your text-based configuration, which means you have that normalized vendor agnostic view of its configuration that you can look at in Security Manager, and you can start doing things like searching on it using those filter bricks or tools like SQL, the Security Intelligence Query Language. Level 3 support is level 2 and 1, and now we're adding in usage analysis, which means we're now tracking for log usage, for rules via syslog or hit counters on those devices, and you can now start using more sophisticated tools like traffic flow analysis to determine what might be flowing through those large any rules or those 10.0.0s. Level 4 on top of level 3 adds on behavior analysis, which means at that level we can now start to analyze routing information, which then enables access path analysis, allowing us to start running those traffic simulations to determine what will or will not pass through a device, given based on its network mapping that we have set up. And finally, there's level 5, or the automation level, wherein we support the ability to actually plan and stage a rule on a device from inside the policy planner application. That feature also includes the capability to create rules, place objects inside them, and actually push the changes to your firewalls if so desired. Automation is a separate layer of licensing. So if you look at your devices in the administration center or panel, you'll see a license for each of the FireMon applications, as well as a checkbox if you wish to use automation to push changes to that device. That's going to allow you to permit automation down to a device level, should that be something you want to do. Let me just show you what that looks like quickly. So you can see here that under the administration panel in the device tab, you will see the license section for each one of your devices and which one of our applications it is allowed to use. So this device on top here is managed for Security Manager, Policy Optimizer, Policy Planner, but not for automation. So I couldn't automatically push changes to this one, although I could for these here that have that checkbox enabled. Side note here, levels of device support, if that's something you're trying to understand, can be found in the administration guide that is available on our user center. And again, that list is constantly growing, so make sure you check in with us if you can't find the level of device support for a particular device. All right, checking device health. We provide a health status dashboard view of all of the devices that are going to be monitored by your FireMon ecosystem in the admin panel. That dashboard is going to show you health data for retrievals, for changes, and for logging. The status on that dashboard is going to display the worst case status at the top level. For example, if your device is retrieving correctly and we're seeing change notifications come in as well, but FireMon hasn't seen any logs for a couple of days on that device, that device would display as red or critical on the dashboard, and you'd be able to drill down in the dashboard to understand the reasons behind that health status. They're fairly verbose, but as always, if you have any doubt, you can open up a support ticket, reach out to a support team, and have it looked at if you're having a device alert. Let me show you what exactly this looks like. Just going to log into a system on the side here. There we go. So here is your device health panel here. You can see that the health status is going to be showing up again at the top level. And if you're interested in understanding why a particular device is being shown as critical health, for example, let's take that Cisco ASA firewall, and then you can do the drop down here and look at the various sections of it. You can see that this device is in fact licensed. It does have a data collector group assigned. It is successfully being, retrieving its configuration, and you can see the revision ID for the last successful one that was pulled down. It is able to detect change monitoring, so that's configured as well, although the last change was received by a manual retrieval instead of automatic retrieval, and it is turned critical because FireMon has not seen usage data here for more than 2 days, which is also a configurable threshold, by the way. If you have quiet devices that are hidden somewhere deep in your network that never see any usage, you could change that threshold or actually stop the usage monitoring completely if you didn't want to see those critical alerts popping up all the time based on the expiry of the time it takes to get usage data. Excuse me. Device groups, well, I think we were just covering those a few minutes ago, but there are a few important parts to remember about them that are worth repeating. So we're always going to want to organize our devices under device groups. Remember that everything will be part of the all devices group by default when you bring it into your FireMon ecosystem. It is totally up to you how you organize your device groups. You could again do it by geographical distinction or devices, perhaps by criticality, or if you have other compliance requirements like PCI or HIPAA, you might want to group your devices accordingly. And again, you can nest device groups within other device groups, and a device can belong in more than one device group as well, which will provide you with total flexibility on how you want to organize them. Also, just on a side here, device groups that are going to represent networks should have behavior analysis enabled when you create them, which will allow you to do those traffic simulations for access path analysis and network mapping. Oh, yesterday we went over reporting and we ran some one-off reports out of Security Manager, and we also looked at how you would go about setting up scheduled or emailing out reports from the administration panel. Just a quick reminder here, scheduled reports are going to be viewed from the Security Manager application in your My Reports tab, but they actually get configured or set up to be sent via email inside the administration panel application, whereas those one-off reports that you can run directly out of Security Manager. So a quick note here on reports, they should typically be done or restricted in functionality to administrators as opposed to regular users in your FireMon ecosystem. Keep in mind that reports will be using up your system resources. They are fairly system intensive when they run, and they will also be sitting on the disk for a default time of 14 days. So you have to maintain control over how many get set up and how many get fired off to run at the same time. Generally best to lock down that ability to avoid rampant overuse of your system resources. Also, if you're going to be doing a lot of reporting as one of your main use cases, you can also adjust the retention settings from that Security Manager page of the settings tab in your admin app. And again, that default retention period for your reports that have been run is 14 days. You can always lower that or increase it as required. And you can also adjust the time it takes to generate a PDF of a report. If there's sometimes a little error message you get, a large report might time out and tell you that it didn't have time to generate the PDF, you can up that time. Those adjustments would be made in the Security Manager page in the settings tab here of the admin panel. I'll just show you what that looks like, because that's a fairly common functionality as well. If you go over here in the administration panel in the settings tab in Security Manager, and scroll down here, and you can see, where's my reporting session? There you go. You are going to be keeping them by default for 14 days in your My Reports tab, and you have all of 5 minutes or 300 seconds to generate the PDF, or it will time out through your Security Manager application when you're using it. So if you do get a timeout, you can come in here and increase this. And if you're getting low on disk space, you might want to shorten the amount of time that you keep those reports hanging around for, sitting on your disk in the database. Also, a neat little trick here, if you get your hands on your corporate logo, you can upload it to your application server here using the upload button, your standard PNG, JPEG file. And then all of your reports will have your own logo at the top of the pages. You can tell that hacked and set up in the FireMon ecosystem and maintain, again, your reputation as a miracle worker. All right, this brings us to the end of the overview of your administration features. Let's go over a few important points you want to take away. Device addition in the SIP or Security Intelligence Platform is going to be a 3-step process. First, you're going to configure a device so that the data collector can connect to it and receive its logs. Then you'll add it to your Security Manager infrastructure and verify communication to it through a manual retrieval to make sure you're able to pull it. The data collector is going to be the component that retrieves device configurations and log data. If you have a large amount of devices, you can add additional data collectors to scale your Security Manager to your environment. Something important that wasn't mentioned yet also, the data collector that retrieves the configuration of one of your devices should also be the data collector that's going to be listening for log data from that device to detect changes or updates in the traffic usage. You can view your data collector and its operational status, as well as a list of monitored devices for it from the Administration Center or Administration Panel. The Security Manager app is only going to monitor devices that are licensed. So if you're running out of licenses, you can either unlicense unused ones and shift them around, or purchase more licenses to keep them all nice and licensed and make sure you don't lose any usage. If you're using syslog, those logs are going to need to be forwarded to the data collector in order to collect change and usage data. In the case of checkpoint firewalls, the data collector needs to connect to the checkpoint log server over LIA to retrieve those logs. And finally, if you intend to use the behavioral analysis features in the Security Manager, you should set up the map. All right. So we've been going at it for roughly an hour. Let's take a quick 20-minute break at this point, and we will resume. I have 10 minutes to the hour. We'll resume at 10 minutes past the hour. We'll just take a quick break at this point, let you make any phone calls or do any emailing you want us to do. All right, I'm looking at 10 minutes past the hour. Let's jump back into it. Let's take a look now at Policy Optimizer, which is our workflow application, and this one is designed for continuous compliance review of your firewall rules. With this tool, you can enable automated or manual review and certification of your firewall rules so that your auditors and compliance teams don't have to go through countless firewall policies in order to perform that rule review and certification. Some of the key capabilities of Policy Optimizer include automated policy review, which we just noted. It also uses event-driven enrollment, meaning it'll automatically open Policy Optimizer tickets based on conditions you may have set. And it also provides for a continuous performance improvement and allows for third-party integration. And of course, Policy Optimizer comes with a default workflow out of the box, which of course can be customized to meet your needs through engagement with our professional services team if the default workflow doesn't quite meet your needs. A little more on those key capabilities, starting with automated policy review. So this feature is going to provide the details of any compliance violations, whether they be regulatory or internal, to ensure that your policy enforcement or compliance people can instantly recertify or decertify your firewall rules according to whatever those compliance policies and violations are, and help you maintain airtight policies on your firewalls. Excuse me. Policy Optimizer provides event-driven enrollment and can trigger rule review processes based on real-world events, security concerns, or compliance drifts, or other defined thresholds that you might set up. What that really means is you can configure when a rule review gets triggered. It can be manual, and we'll actually demonstrate that shortly, or it can also be when a configuration change is detected that trips one of those security controls that we set up in the compliance section, or perhaps when a rule is flagged to expire, you could trigger that review as well. The performance improvement capability refers back to the KPIs that are going to be available on the dashboard for Policy Optimizer, which are going to allow you to see the effects of rules and determine the security risk, as well as change policies in order to fortify your security policy in response. So in addition to letting you watch your security trends at a dashboard level, Policy Optimizer provides the people who are tasked with that rule review with all of the pertinent information associated to a given firewall rule in order to help them make informed decisions on whether or not that rule should continue to exist. On the subject of third-party integration, Policy Optimizer is a workflow-based tool with built on RESTful APIs. So that's going to allow the tool to be integrated with your current processes and through API calls integrated with any of your offboard tools. If you have some kind of compliance tool already in use, you can set up Policy Optimizer so that that tool can pull information from Policy Optimizer or even open Policy Optimizer or Policy Planner tickets in response to certain events that you might configure. We haven't really looked into APIs yet, so just in case you're wondering what that's about, we'll be touching on them shortly as well. And last but not least, Policy Optimizer does come with a default workflow out of the box, which, as always, can be completely customized, or we could even create entirely new workflow for you to match your specific requirements for your organization. So that's a pretty high-level view of what Policy Optimizer is. Let me actually show you it in action so you can get a better understanding of what this is going to do for your organization. So first, we're going to go over the Security Manager application because that's pretty much where everything starts in one way or another when you're talking firewall rules. So you are looking here at your policy and security rules for all of the devices in the enterprise group. So generally speaking, if we wanted to manually send a rule up to be reviewed, for example, it would generally be some ugly rule like an any except. Look at that, we have one right here. It is the implicit level, but it'll do just for the purpose of demonstration. So if we wanted to have this rule reviewed for the purposes of compliance through Policy Optimizer, we could simply come over to the right side menu here and select this route to Policy Optimizer item right there. and that's going to tell us that we have submitted this rule for review, which presumably will automatically trigger an email depending on the workflow configuration going out to our compliance team, telling them that there has been a review ticket assigned to them, and they should go in there and take a look at whether this rule should continue to exist, presumably in the context of whatever compliance requirements they might have to meet. So once that rule has been sent up, we can switch over to the policy optimizer application here just by doing the dropdown. And now we can see that they're going to be presented with a list of the current policy optimizer tickets. And I can see how many review tickets are floating in here that are waiting to be done. If I want to just see the new ones, I can go up here and click Rule Review and select the new Rule Review item. And I'll see that there have been only 2 created in the last 5 days. There's probably one of them is going to be the one that I just sent up. There we go, 9:15 at 11:14 a.m. my time. And it's been assigned the ticket number Policy Optimizer, or PO-267. And that's basically what's going to happen is it's going to be assigned a PO preface and then a dash and whichever number. It's going to start at 1 and keep working its way up until I'm not sure how far it can go. That's a good question. I'm going to look that one up. All right, so once I click on that policy optimizer ticket, I'm coming in here now as a compliance person who is assigned the duty of deciding whether or not this rule should continue to exist, because somebody has told me I need to review it. This one was sent up to Policy Optimizer manually. However, it's more typical to have a ticket automatically opened in Policy Optimizer when some of those controls that we were looking at for compliance yesterday fail. If you actually go into the administration panel under the compliance tab and look at some of those controls, you can see that there is an option to check a box in there in the Policy Optimizer section that would actually send that ticket up to be reviewed whenever one of those compliance controls fails. Let me show you actually where that looks like here. So once again, once you're setting up those compliance controls, if you're setting up a control and you wish to have a Policy Optimizer ticket opened whenever one of these controls gets tripped, then you would select this radio button right here, the Send Failed Rules to Policy Optimizer. So whenever this control gets triggered, that Policy Optimizer ticket that would look like this, it would get opened. And if you have email set up to go to a particular user group to complete that, then they would get an email telling them that somebody is asking them to review this particular rule to make sure it should stay in place. So again, you can see here that they have these views, the complete security rule view in that vendor agnostic format, and they are going to be asked to provide either certification or decertification of this rule from the compliance perspective. If they want more information, there might be details provided if the ticket was manually opened or some comments from the person who opened the ticket. If there's some kind of external attachment form that's going to be used as part of your compliance processes, you could attach those here, and there will always be a task history showing you what has happened with the current task, which is the review stage here, and the review history will keep growing as this ticket moves forward, which will provide you with an audit trail of all of the review for this particular ticket. So as the compliance user, I get to go ahead and look at what this change or this rule is that exists because somebody has told me that it shouldn't be here for some reason, and then I will have to make a decision and either certify or decertify the rule from a compliance perspective. If I choose to decertify it, I can specify that this rule should either be removed or modified and add my remarks as to why and what it is I'd like to see changed. If I would want to certify the rule, then I will be asked to set up some sort of remarks telling me why it's approved. And then I will need to set a next review date, which is when the next review date will automatically trigger the next policy review of this rule, so that Policy Optimizer will automatically open a ticket at whatever date I set here. For example, if this were PCI firewall, you'd go 6 months down the road and trigger another review for 6 months to stay in compliance with that 6-month rule review requirement for PCI. So once I've done that and I've entered the fields that need to be populated, I can go ahead and click Save as the compliance turn, and the pop-up toast here will tell me that I've successfully updated that review. And you can see that the change, the task history just got a little longer, telling me that I have certified that here and what the comments are that got put in. And once all that gets completed, I can click Just Complete, and you can see that I have now closed the ticket and the task has now been marked as completed. Pardon me. All right, so that's pretty much it for what Policy Optimizer is going to do for you. It is a very powerful tool from the compliance perspective. Let's go over a few important related points to take away. Policy Optimizer is one of those add-on applications that you can add into your Security Manager or FireMon ecosystem or suite of tools. If you don't have it already but are interested in purchasing it for the purposes of tracking compliance, contact your account representative who would be able to hook you up with a sales engineer and do a demo tailored to your particular needs. It is, of course, a rule review tool that is designed to let your compliance people certify or decertify firewall rules, typically in accordance to some form of compliance violation. It's going to provide those reviewers with that single pane of glass analysis of a rule's compliance, which is going to be performed during the review process. So this ties neatly back to those compliance assessments that we looked at yesterday. Everything that we analyze in Security Manager for a device is going to be factored in to that Policy Optimizer view that the users will see when they're looking at a ticket to make a decision whether or not it should continue to exist. Those compliance users will also see the documentation and rule review history. So in a nutshell, they're going to have everything they need to know about a particular firewall rule to make an informed decision on whether they should certify the rule or not. And as noted, those can be done manually or automatically, the rules assigned up to the Policy Optimizer application for review. Pardon me. All right, next up is our Policy Planner application, which is kind of the sister application to Policy Optimizer because they're both based on workflows which are fully customizable. Policy Optimizer is going to be considerably more in-depth since it has been created to allow you to create and track all of your firewall changes from within your Policy Planner app. So a little bit on the core functionality for Policy Planner. It is in fact a ticketing system that will document and notify users at all of the key steps for managing your network security changes. It will also allow you to manage risk and compliance factors in the decision-making process through the various stages of those changes. Policy Planner can also update all of that rule documentation once the review stage gets completed and the ticket gets completed. If you have specified the documentation fields within that ticket, they will get updated in that particular firewall rule. Policy Planner also has the ability to automatically push or stage changes to your firewalls. And again, that automation is completely optional. You have full control over how much you want to take advantage of automation features out of your Policy Planner application. Policy Planner can also integrate with your existing ticketing systems via quite a bit of out-of-box integrations that we have, or via application programming interfaces if you want to make more custom type interface to your Policy Planner application. Obviously, every organization is going to have their own change management processes and workflows, and that's why Policy Planner is built to be highly customizable, and you would get that customized through the help of our professional services team to make it behave in a particular way that you need. Right, much like in Security Manager, Policy Planner is going to have a KPI and widget dashboard that's going to show you things at a user level, such as tickets that are assigned to you, tickets that are due in the next 7 days, and tickets that are available to claim, which would be tickets pending review or implementation, along with tickets that no other user has currently claimed. There's also a management-centric dashboard where managers would be able to find handy metrics on how fast tickets are being completed over the last 30-day period, as well as an average ticket age and how many tickets might have been canceled in the last 30 days. And then finally, there's an operations-centric dashboard also where your ops staff can find things like the number of open tickets, the number of open tickets being managed for a selected domain, how many tickets have been created in the last 30 days, and how many have been closed in the last 30 days. Let's actually take a look at those dashboards here to show you what they look like. Frog in my throat this morning. All right, here's the user dashboard that's going to show me the tickets that are assigned to whichever user is logged into the system Policy Planner at this point, and it is me, as you can see up here. You can see that there are, in fact, 9 tickets assigned to me. 4 of them are high priority Policy Planner tickets or firewall changes. I have none due in the next 7 days, and there are 20 tickets overall available to claim in the ticketing queue, which simply haven't been claimed by any other users. And again, there is also a management level dashboard, and here we'll be able to see how many tickets have been done over the last 30 days, what the average ticket age is and how many have been canceled in the last 30 days. And there would also be a task completed by priority list here if I was closing off tickets, and the average completion task of your tasks by month. And finally, there's that operations-based dashboard here, which are going to show your firewall admins or operations staff how many tickets are open in the queue, how many of them are high priority, and how many have been created in the last 30 days and how many have been closed in the last 30 days. It's pretty quiet in the lab, so there's not a lot of tickets getting pushed around. All right, much like in Security Manager and Policy Optimizer, you can also filter your Policy Planner tickets using those either filter bricks or SQL queries. The filter bricks available in Policy Planner will be somewhat more limited than the ones available in Security Manager, purely just for the nature of the application itself. And similarly, you can use multiples of those filter bricks to create a complex query, and then you could view it or modify it and save it by switching to advanced mode, just as you would in your Security Manager application. Or you can also use SQL to create much more complex queries if that's something you need to do. You can also run those SQL queries through API calls, which we'll be looking at shortly. So if you have some form of external ticketing system, such as ServiceNow or Service Manager integrated with your FireMon ecosystem, you could have that ticketing system make an API call to your FireMon ecosystem and run a SQL query to pull back ticket information and populate fields on your external dashboard. All right, when you purchase Policy Planner, it's going to come with a default workflow. That default workflow is going to have 6 stages by default for any change tickets that you create within it. Stage 1 here, request edit, is the first stage when you're creating a Policy Planner change ticket, and that's where users will actually submit the details of the connectivity that they want to request, which presumably your security engineers or firewall people will pick up and start to configure once that request has been submitted. And they would do that in the next stage, which is design. In the design stage, the request has been submitted by a user saying, I need access from A to B over port C. And then your security person will come in here, grab that ticket and design the actual changes necessary so that the connectivity being requested within the requirements is actually enabled. Policy Planner at this stage can also make recommendations on what firewall changes need to actually be done in order to give that person that connectivity, or it can also potentially tell your security people that they don't need to make any changes because that access is already permitted, and it'll tell you which rules are doing it. In the review stage, which would come in next, this is where the firewall engineer or other assigned person, typically a compliance type person, if you need to maintain separation of duties, which is probably a good idea, will look at the work done in the design stage by your firewall person and determine whether or not that needs to be modified, typically due to compliance issues that don't mesh with your compliance policies or things you can and cannot do in your environment. Once that gets reviewed and approved, the ticket would move into the next stage, which is the implement stage, and that can be either manual or automated, as we were discussing. The firewall engineer or administrator would then actually make the firewall changes as directed in the ticket and either push them out manually and stage them, or allow automation to take over and push the change out to your actual firewall devices. Once that change gets pushed out to your device, FireMon will go into the auto verify stage and then the verify stage, and that's where Policy Planner is actually going to look at the changes that were requested in this ticket and check whether those changes were implemented as they were supposed to be. So the first thing it's going to try and do is do it automatically verify, and if it can't automatically verify, it'll time out and shift to a manual verify mode where that same network firewall engineer or security guy is going to come in, assign the ticket to himself, verify it manually, and check that it makes sure it matches the request, as in what was asked for was actually what was implemented. And then once that verify gets completed, the documentation for any rules that were driven out of that ticket will get updated from the fields that are there in Policy Planner, and then it'll move into the final stage, which is complete, where the ticket is done and the ticket gets closed. If you've done any work with Policy Planner in the past, then you've probably seen this graphic, which is a visual representation of that default workflow for your Policy Planner changes. So you can see here that in the create ticket edit request phase is where your users would actually come in and start to request, for example, I need to get access from source A to destination B over port C. They would enter that information into the ticket at this phase and then submit it, where it would go down to the design phase, which is phase number 2, where your firewall or security engineer would come in and look at the request and say, okay, you need the following rules to actually enable that connectivity. Or if there isn't enough information, they can also optionally reject it and send it back to that requester saying, nah, I need more information in order to be able to actually design the rules for you. There's also at the design phase, the option here for Policy Planner to run certain compliance checks before a change actually takes place in order to derive a calculation of the severity of that particular change that's going to take place. And then you could use that if you've modified your workflow to actually route tickets past the review stage if they're going to be pre-approved or simple changes. I actually have a customer who has it set up like that, where anybody can submit a change ticket, and if it's coming from zone A, B, or C to zone E, D, or F, it's okay. It'll get automatically approved and implemented. But if it doesn't meet any of those criteria, it'll then automatically go to a review stage where somebody from their compliance team actually has to approve it. They actually achieved like a 40% reduction in tickets that were hitting their compliance team just by configuring that auto approval. So however, by default, it's going to be manual. So once your firewall engineer or person has designed up that ticket and get it ready to go, they would hit complete, which would send it off to review, which would generally be based on compliance and done by your compliance team, where they would take a look at what was designed here, compare it to your corporate compliance policy or whatever industry compliance standards you need to meet, and say, yeah, it meets them, and go ahead and approve it, or no, it doesn't, send it back. You need to change the following things in order to meet the compliance that you need. And if it's really absurd, something like any except, they might just cancel the ticket and tell you, nah, we're not doing that. So here, if they do approve it, then they will go over to the implement stage again, and that's where the actual changes will get pushed out either manually and then staged onto your firewall management station, where you would have your firewall engineer come back and do it, or automatically, if you have full automation enabled, then it would go ahead and push that out to your device and mark it as complete, and then go into auto verify, where we would run a bunch of checks, which we're going to look at in a second, against that ticket to make sure that what was requested was actually implemented as designed. And it'll try actually 10 times for 10 minutes total to auto verify that ticket and make sure that it matches up between the management station and the device that it actually pushed to. If it can't do that, it'll move it to manual verify, where your firewall engineer, again, with permissions to do a manual verifier, will come in and make that comparison between what was requested and what was actually implemented. And if it was correct, then he will move it into the verify stage, where the documentation for the rules resulting from this change ticket will be updated, and then the ticket will be marked complete, and off you go. You have a new firewall rule in place. All right, a little bit on policy planner permissions, which we were just looking at earlier from a user group perspective. And this is where we're getting into the more details about the ability to be very granular on those permissions. Let me actually, once again, show you that these match up. Here you are in your administration panel looking at your user group permissions, and you can see that in the workflow tab, these are the permissions for the various stages of your policy planner ticket. And you can give user groups very granular permissions on which stage they are allowed to interact with these policy planner tickets with, and what they can and cannot do for your particular policy planner workflow that you want configured. So users who have the view packet permission are going to be able to view tickets for a specific workflow. In the back end, by the way, of Policy Planner, tickets are actually called packets. So when you see the word packet in here, just think ticket. Not sure why it was called packets, but it's been around for a long time, but there it is. Packet means ticket when you're talking Policy Planner. So the view secure permission remains unused as of current release versions, and it is one of those request for enhancement items that came in from a highly secure conscious government type entity that wanted to be able to grant access to fields which contain sensitive data. So as we move forward, you're likely to see that view secure permission come into play a little bit more. The create packet / ticket is going to allow users to actually create ticket in this workflow or a specific workflow. You can have more than one if you wish. The design auto verify wait permission, is going to allow users the ability to move tickets from auto verify if they can't get, an auto verify in 10 tries of 10 minutes over to the manual verify stage. Should they need to, and then they would be able to actually manually compare what was requested against what was actually implemented. The design permission is going to allow a user to actually design the changes within the ticket, add the sources, destinations, and actually start configuring that firewall rule per the requested connectivity in the view packet, the edit request phase. The edit request permission is going to allow a user to ask for changes in the ticket requirements, as in actually tell me I want destination A to be able to get talked to from source A over port C. And finally, you have this review permission here. If you have the permission to review these tickets, typically is going to be assigned to your compliance people who will have the ability to go in there and look at the proposed change tickets and approve or reject them, or request more information on a ticket before doing either, typically based on your particular compliance requirements. Users with the implement permission are going to be able to actually view the design and push the change out to one of your devices. And users who have the verify permission are going to be able to actually manually perform a verification of the ticket to ensure that it matches up what it was supposed to do. All right, one of the more powerful features of Policy Planner application is the rule recommendation feature. Rule Rec, as we call it, is going to use Security Manager's behavior analysis capabilities to make rule recommendations, as in you need to put a rule here on this firewall to enable the connectivity that's being asked for on this particular ticket. So what that means is that the information that's contained about your firewalls in Security Manager is going to be compared against the requirements specified in a Policy Planner ticket or packet, and make recommendations on what changes you actually need to make to any firewall rules and where to apply them in order to provide the requested access. Pardon me. Firewalls must support behavioral analysis, which is level 4, as we were looking at briefly a little while ago, just for rule recommendation to actually work. So in a nutshell, Rule Rec is going to present your change people or your firewall engineers with recommendations on what rules need to be created and where in order to actually accomplish the connectivity that's being requested. Conversely, Rule Rec might also tell your firewall engineer that they don't need to do anything since it found a rule that already exists for the access being requested. So the intelligence behind Rule Rec is constantly improving. However, it's generally still advisable to have someone who understands your firewall environment check those rule recommendations and verify that they make sense prior to actually pushing them out to your devices. There's also at this stage going to be some compliance checks that you can run against those recommendations provided, as well as also against any manually created changes you might put in the Policy Planner. All right, we have a couple of different match methods for making those rule recommendations to determine where a firewall change might need to go. FireMon is going to use behavioral analysis as well as define device routing and default route information to make a determination of the most likely target firewalls on which those changes need to go. What that all boils down to is that FireMon is going to use all of the information it has about your individual devices in Security Manager to help make the best possible recommendations on where to put that change to enable that connectivity. So change automation, which takes place at the implement stage of a Policy Planner ticket, is going to allow changes defined in Policy Planner to actually be pushed to your devices. Pardon me. You can also define change. Pardon me. You can also define change or enforcement windows to control when that push actually takes place. Depending on the device, Policy Planner changes are going to be either staged or pushed. If the change is staged, that means that somebody's going to need to log into the device or its management station and actually push the policy. And if it gets pushed, that means you've enabled automation, and FireMon will actually do that for you. All right, and the automation scheme enforcement windows are going to be used to determine when those changes actually push. So again, if you select the continuous option, that means that as soon as your policy planner ticket reaches the approved stage, it will be pushed out to your device. If you set it up to scheduled, that means that you can allow the creation of a unique change schedule at a single device level, and whenever a change ticket gets approved in Policy Planner, then the Policy Planner application will wait for that scheduled window and then push the change out to your device automatically. And then you also have the device to create those global device change windows options, which are going to create that system-wide change window that you set up in your administration panel, which will then be used to determine whether or not the related compliance checks pass or fail, i.e. has somebody pushed a change to my devices outside of my approved window. And of course, finally, there's manual only, which means the change is only going to be staged and wait until someone actually logs into the device or management station and pushes it out to the device. All right, let's get into a little bit about what auto verification does when it's running for 10 minutes, 10 times. After a change is implemented in the Policy Planner application, once it gets past that stage, it moves into that auto verification stage where there are 4 checks that could potentially be run depending on the device on which the change was implemented and depending on how each one of these checks goes through. If some of them go through, then others will be skipped, and that's pretty much just makes sense. We'll walk through it in a second here. Management station match is going to take place on devices that have a management station, and wherein FireMon will first identify the device that a change was made to, and then go into Security Manager and determine its parent device, which would be a CMA for Checkpoint, a Panorama for Palo Alto, et cetera, and then FireMon is going to attempt to verify or identify if those new rules exist on the management level, and finally verify the properties of the rule, i.e. the source, destination, ports, and so on, and make sure that they actually match up with that rule. The next change check will be the change control number matching. And in here, Policy Planner is actually going to search for the rule that was found in the previous check, the management station match above. And then it'll go down and look in the rule documentation to make sure that there is a Policy Planner ticket number that matches up what was pushed. The third potential check is the rule search match, and this is where Policy Planner is going to identify a device that the rule modification took place on, as well as its management station. And then it's going to try and verify that the rule exists on both the gateway or firewall and the management station that manages it. And then it'll go ahead and verify all the properties of the rule again, the source, destination, service, users, et cetera, et cetera. If the management station match from the previous slide passes, then this third check gets skipped. And finally, there'll be a syslog association match. If syslog messages indicating that a change has occurred get detected by FireMon, then it'll do a change log association match, which will identify the device on which a change took place, and then search the change logs of that device for a window when that notification should have happened. And if it does not match with your device window, then it'll trigger that compliance control telling you somebody pushed outside your defined window. All right, I'm going to move over onto a lab box where I have some of this set up and show you an actual Policy Planner ticket in process so you can see how we go about setting one of these up. You just have to log in again. All right, so here we are in the Policy Planner application as opposed to the Security Manager or Administration app. And now what we're going to do here is create a ticket. Of course, we have this dashboard here to show you what tickets are already there waiting for you, if there's any unassigned by ticket type. If there's any tickets that need to be processed, you can come and look at them here. You can actually also look at a whole list of your Policy Planner tickets that are sitting here waiting to be processed if there are any there. But if you have a user that wants to request new connectivity, they would simply do so by hitting the Create Ticket button here, and then they'll be taken to this summary field where they are going to need to fill in anything that has a red asterisk, which is basically the initial screen where your user is going to provide the high-level details of what connectivity they are requesting from your firewall people to come in and design. we'll just put something simple. If you have some kind of external form, a lot of places use Word documents / Excel files to trigger their change processes and get attached to Service Manager tickets or ServiceNow tickets. You can attach them here in your FireMon ecosystem as well, and that attachment will follow this ticket along throughout its entire life, which is going to be kind of handy for audit trails if you have compliance audits as part of your requirements. And once you've provided notes to your firewall guy, give them as much detail as you possibly can so that they have the best chance at giving you the connectivity that you're actually looking for. Then you'll click the next button as a user, and it'll show you that you have now created a new change management ticket, CM, and it'll give it a number automatically, which will increment as they go. You will notice that I am now in the field where I'm going to have to provide the requirements or the source, destination, and so on that I'm looking for, and that I'm now in the edit request stage of this policy planner ticket. Again, you'll have fields here that will have red asterisks that mean they must be filled out. Some of these you will find that they match up with the documentation fields of some of the rules that get created from on this. So if you actually fill these out, which you have to, these will actually populate those documentation fields in the resulting rules. I'll just put in some text because they're mandatory. So the priority here, this is where when those tickets show up as high priority or whatnot in the various KPIs, this is where that gets set. Of course, it's a firewall change, so they're always going to be high priority. And the due date, it has to be in the future. You can't go yesterday. Sorry, project managers, but that's how it's going to be set up today. And here's that customer field where we can decide which customer is going to own this particular rule for us to be able to do that kind of filtering. If you don't have integration set up with your offboard ticketing system, but you do want to make a reference to that particular ticket for the purposes of being able to connect your policy planner tickets with your external system IDs, you can enter that external ticket ID here, which will be another one of those documentation fields that'll show up in the rule to allow you to get that audit trail nice and wrapped up neatly. Business need is also one of those documentation fields that will get filled in when this ticket gets completed in whatever rules result from it. And that's going to be really handy if you have compliance requirements in particular. Oftentimes you need to justify, who approved the rule and why that rule exists for most compliance purposes. And this business need is a good application as to why that should happen. Down here, you can add more comments in if you wish to instruct your firewall people on what it is you're actually looking to do. If you have external forms that you need to attach, spreadsheets or whatever it is, you can attach them here so they follow along with your ticket. There's also going to be a task history of what it is you're doing right now as the requester. And the ticket history here is going to get bigger as we step through each phase or stage of this policy planner ticket. And this is where you're going to get a full audit trail to be able to understand who approved it, who asked for it, and each stage of the ticket, you'll see who's touched it. Great thing to have if you have compliance audits as part of something you need. So obviously, I'm asking for connectivity to be enabled through a firewall change, so I need to specify some kind of requirement, source, destination, and a destination. I could import those requirements if I wish. I could add connectivity and they'll pull in those requirements through a spreadsheet, or I could manage a native object if I'm a high-end user and I really know my firewall stuff and I have access to them. I could actually go in there and start committing that right away if I wanted to in default mode. Or more common would be just to use add requirement. And again, I could manage a native object if I had access to it, or just request for connectivity. In particular, provide a source, a destination, and a service that I'm looking to have opened up with this policy planner change ticket. So I'll use a source of 192.168.5.77 and a destination of 10.0.1.78. And I want the ports SSH or TCP22 open between these two devices. And of course, the accent would be accept because I want this to actually come through here. Some devices are going to specify that you need to provide a user ID, and others will specify application. That's true of a lot of Palo Altos or Fortinets. You'll see those fields becoming necessary. I can provide an expiration date. This is a documentation field that's going to live in the associated rules for this policy planner change ticket. They will not actually turn off the connectivity when the date expires. However, they will allow you to perform searches based on expiration date to find out what rules might you have in your environment that are about to expire next month. You could set up even like a monthly report showing you next month these tickets are going to expire or these rules are going to expire, so you should probably get them all reviewed now. The review date, however, it will automatically open one of those policy optimizer tickets. So if you have compliance requirements that specify a particular length of time between firewall rule reviews, this is where you can enforce that if you are a consumer of that policy optimizer application. This is also something that will show up in your documentation fields, but this one you can actually automate a policy optimizer ticket being open. So for example, if I had a PCI firewall here that I'm pushing rules to, I would set this review date to 6 months from now so that I could always have my 6-month review requirement met. So once I have the details of a particular connectivity that I'm asking for set up, I will click save on that particular requirement. I can add more than one if I wish. Keeping in mind that Policy Planner, if it does pre-change assessments, will trigger on the first one that it meets and approve the ticket. And you can see here that I have successfully updated the requirement for that ticket. If I am good with these requirements as the requester, I will go ahead and click save to save the entire ticket, and I'll be told that I have actually updated the change management 232 ticket. And then once I click submit, you can see here that I have done with that task. And I have gone ahead and successfully updated the ticket. You can see those pop-up toasts show up. These pretty much give you information on everything that you're doing in FireMon. You can turn those off optionally. In particularly huge environments, sometimes those pop-up toasts will start coming in whenever a change gets detected on any of your firewalls. If you have thousands of firewalls, it's a constant windows popping up, so there is the ability to actually turn that off if so required. So you'll notice now that I have actually moved this ticket now into stage 2, which is the design stage of my Policy Planner ticket. And you can see here that I now have change management 232 waiting. So typically there would be a separation of duties here, and it wouldn't be me doing all of these things. I would not be the requester, the designer, and the approver, but for the purpose of demonstrating, I'll be all of the above. So right now I'll put on my firewall guy hat and assign this ticket to myself in the design stage. And you can see again through those pop-up toasts that I have now been assigned this ticket. And as the firewall guy, I'll come in here and take a look at what's being requested by that user. Again, if there were comments added here, I could look at them if there was an external form attached. And again, there's that ticket history, and you can see that it's starting to get longer with each action that takes place on this particular change ticket. That audit trail will continue to grow, allowing me to be able to show the complete audit trail to any auditor that needs to see it. So back in the design tab, if I'm good with those recommendations, I could, if I was really, familiar with my firewall environment as a firewall guy working on this, I could just go in here, click the add change button, and go ahead and add it into the firewall that I know this IP addresses will hit. Or I can allow RuleRec to kick in and tell me where it thinks I'm actually going to need to apply this. So if I click recommendation, I will be asked which devices I think this thing will go to. If I click all devices, it's going to take a while to think about it as it steps through those access path analysis based on that source, destination, IP, and port. I happen to know that this is going to hit this Cisco firewall, so I'll just choose that one to let it do its thing a little quicker. And we'll hit that one. All right, and once you click next, you will see RuleRec start to do its thing and analyze that Cisco firewall based on the source, destination, and service. And you can see now that RuleRec has looked at the policy in there and said that I need to add a rule on the inside access in policy, and I need to add a rule also on this global access policy on that Cisco firewall. However, I do not need to add a rule to the outside access out policy because there's already a rule there that matches this access and will allow that to go through. If I want more details on that, I can click the explain button here on the right tab and see that FireMon is telling me that I should probably add this rule below this rule for this action to actually take place, for this connectivity to work. And in the global access policy, I need to add this rule above this rule for this access to actually work. So once I'm good with that, I can click next again, and I'm the designer here looking at this. And once I'm happy with everything I see and everything looks pretty good, I can see the objects are going to created in order to drive this through. And I will click finish. And I will see that I have successfully updated the requirements. And now I can actually see what objects are going to be created on this Cisco in order to create this rule. And I can get the details of what's going to happen there. And once I'm happy with that, I can hit complete. And this should go ahead and take a look at that, set up the ticket to run, and send it up to the next stage, which would be the review stage, where in theory, the next guy who would be a compliance person would come in here, probably get an email as a result of this workflow telling them, hey, somebody submitted a ticket, you need to go review it. That person would come in here, and now I'll put on my compliance guy hat and assign it to myself yet again. And you can see now that it is in fact in the review stage up here, and I've assigned it to myself to review because I am now a compliance guy, jack of all trades, of course. And you can see here that I now can look at this particular ticket that's being requested. I can look at the change plan if I want to understand what they're about to do, which will tell me that these objects are getting created. I can even go so far as to understand exactly what CLI commands are going to be issued to the Cisco firewall in order to enable this connectivity that's being requested. Once I'm satisfied with all that, I can decide whether or not this gets approved or not. I'm the guy to do it, since I am now the compliance guy. Again, if there were comments, I could look at that tab. I could look at the tag history, and there's that ticket history again that is going to follow this policy planner change ticket all the way through. And you can see that it is once again starting to grow as each stage goes through. I have that full audit trail to be able to tell anybody who wants to know what happened to this ticket from beginning to end and how it came to be. So as the approver, I need to approve each requirement in a change as well as the entire ticket. So if there's more than one requirement, I'm going to have to click approve for each one. I can do that by just clicking the approve button on this particular requirement. And just for the sake of doing this quickly, I'll just tell you it's approved and it is in approved status. And once I go ahead and save that, I will actually be able to approve the entire ticket, which I have done. And you can see here that the ticket review is now completed, and I've successfully updated my ticket. And I've now moved to the implement stage, and you can see that automation has not been enabled because it's waiting for me to come in here and push it. And you can see here that it is in here waiting to do so, and it's pending on that for me to push it out. Again, if I look at the selected ticket history here, you can see that now I'm down to the implement stage, and it was approved prior. So I've got that full audit trail sitting here waiting for me if I want to see it. So I'll put my firewall guy hat back on, and I will assign this ticket to myself to implement it. And once I've done that, you can see that it's still in the implement stage, and I've now assigned it to myself. And again, I can come and look at the change plan and take a look at what it was that has been requested. And once I'm happy with what's about to get pushed out, I can go ahead and select that target firewall. And once I've done that and click complete, policy planner will go ahead and push that change out to that firewall. So once I've hit complete, there you go. You can see that the implementation has been completed and that I've successfully updated that ticket. And it's now gone into auto verify wait stage, where it's going to try 10 times for 10 minutes to verify that what was requested here in the ticket, this source, this destination, and this service was actually what got pushed out to that Cisco firewall after hitting the implement button. And you can see here that it's pending while it waits and figures out that 10 minutes over 10 times. I don't think we want to sit here and wait for 100 minutes, so we'll just assume that it's going to go through. But that's essentially how your policy planner ticket it works. That's how you set up all of the fields necessary, the source, destinations, everything, allow your requesters to request those, and allow your firewall people and compliance people to both implement and approve the ticket as part of your change ticketing workflow. That's the walkthrough we just did right there. All right, we also have a good deal of integration policy with Policy Planner as well as Policy Optimizer to tie into your existing ticketing workflows or systems. We can integrate with ServiceNow, Remedy, Service Manager, or you could use APIs to integrate with pretty much anything that can make an API call back to Policy Planner. So that means tickets created in your current system could generate tickets inside Policy Planner or vice versa. We could do things like automatic ticket assignments, perhaps based on who's on call according to your ticketing system that Policy Planner can talk to. We could set this to automatically close tickets in your current system when the ticket gets closed in Policy Planner. And also you could update fields between your current system and the fields in Policy Planner that you would tie together. This is another area where you would work with our professional services team to get that kind of customization work completed. All right, next up is our Risk Analyzer module. So let's talk about some of the core use cases for your Risk Analyzer module. There really are three primary use cases for Risk Analyzer. It's going to analyze vulnerabilities and their potential impact on your assets to help you measure the network risk and prioritize, the highest risk vulnerabilities for remediation in your environment. It'll also help you analyze risk attack vectors and allow you to create what-if scenarios, which could help you refine your firewall policies to reduce that risk exposure if for some reason you can't get the patches laid out fast enough by your support teams. And it'll also provide you with visibility into the ability to actually run an attack from specific locations in your network and map out those paths for the attack visually to help you simulate those attacks and identify potential weaknesses in your network that you might want to plug up. So in order to evaluate the vulnerabilities that exist on your managed assets, you're going to need to provide Risk Analyzer with some form of vulnerability data or definitions. Risk Analyzer uses the CVE, or Common Vulnerabilities and Exposures data from the NIST National Vulnerability Database, which you probably know as the NVD if you are at all involved with any kind of vulnerability scanning. So we use that to detect network vulnerabilities and define them, as well as create attack graphs and perform risk calculations on your network. You can also import vulnerability definitions into the administration center of your SIP, either manually or through a direct connection to the NVD, which will keep you constantly up to date on new definitions if you have that set up to constantly talk. Risk Analyzer also has native support for many third-party vulnerability scanners in order to pull in the actual scan data from your devices to overlay them on your network path. So you could talk to scanners like Qualys, Nessus, Nexpose Raw, Tripwire, Tenable. You can connect them directly to import that scan data, or you can also pull in that scan data through CSV files via an API call to pull in all that data. So let me actually show you some of that in real time in the lab. So we're here in the Risk Analyzer tab here, and we are here in Risk Analyzer page where you can actually look at the vulnerability data source, and that's where you would set up your connection to the NVD. If you wanted to set that up, you could do that here, give it a name, give it a URL, which is obviously going to be this one, and whatever the version is for it, you can test the connection. And once that's set up, then FireMon in the Risk Analyzer is constantly going to be kept update with new definitions from the NVD, or you could, if you want to do it manually, just set up that connection and retrieve now, or do it on a scheduled basis, or bring it in manually. If you want to pull in scan data from your scanners, you would add them here at the scan data source. This is where you can set them up to either talk to it. For example, Qualys is a pretty common one. You would provide the name of your Qualys scanner, what its URL is, and credentials to be able to access that scan data. And then you would be able to pull that scan data down whenever there's new scans of your environment, which Risk Analyzer will then take an overlay on top of your network map to show you where you have vulnerable assets that exist and what rules in your firewalls allow those vulnerabilities to be exploited. All right, similar to other SIP modules, Risk Analyzer is going to provide you with an overview dashboard, and that's going to have KPIs and widgets, except now they're going to be more specific to the vulnerability data that is going to be living in your environment. And let's start that off with the risk overview dashboard here. So here you go, you now have these KPIs up top that are going to show you things like this. How many assets you have in your environment now with vulnerabilities, and that's according to the scan data that you just pulled in from your Qualys or other type of scanner. It'll also show you the count of critical vulnerabilities, and you also have this vulnerability density KPI up here, which is the ratio of total vulnerabilities to total assets in the device group that you're analyzing, which is the risk analyzer device group in this case. And that vulnerability density is going to be set by your data from your scanners. So below that, you have a widget for asset to vulnerability trending. Normally, you would see a black line here representing your vulnerabilities going down. The lab doesn't have, this is dummy scan data. We don't actually have a connection. And then you have your number of assets would have a blue line going up. So in an ideal world, you'd see a black line going down this way, a blue line going up that way. And that tells you that you are adding assets, but reducing vulnerabilities as you go. So things would be good. Next to that, you have this riskiest assets widget, which is going to show you which of your assets have the most severe CVS rating as assigned by your scan data source, which in our case is the NVD or National Vulnerability Database. Scrolling down further here in the dashboard, you can see the most common vulnerabilities existing in your environment, along with some information on how old that vulnerability happens to be, which can be important from an audit compliance point of view. You're also going to be able to see information about how many assets you have that are affected by that particular vulnerability here in this column. Below that, you also have this widget here displaying the 10 riskiest rules in your environment and the specifics of which device they exist on, what that rule number and name is, which you can drill down on for more information to understand how those allow those vulnerabilities to sneak through your network. Excuse me. All right, if I switch over here to the Asset tab in Risk Analyzer, this is where you can get a list of all of the assets that live in the device group that you are analyzing, which have unpatched vulnerabilities. It's also going to provide you with the asset value, as you can see here, which is a metric imported from your scan vendor that defines the criticality of a given asset in your environment. There's also this asset risk score here, which is going to be the level of risk for this particular asset relative to the other assets in the same device group. If you click on the asset name, which in this case is an IP address in the lab here, you're going to be shown the actual risk information for this particular asset, including the vulnerabilities, the risk score of the asset, and the list of rules that are exposing the vulnerabilities on this asset. You can actually see those rules if you just click on them, and those are the ones that are actually allowing that particular vulnerability to flow. Next to that, you will see the list of vulnerabilities on each of that. If you can see here, there's different types of them here. So you have the root type, which is going to be the most severe type of vulnerability, and that's ones that will allow an attacker to actually escalate to admin or root level on the target assets, which is obviously the worst case scenario from the vulnerability perspective. You don't want people getting root access or admin access on your boxes. They could do a lot of bad things. The user type vulnerability refers to vulnerabilities that only allow an attacker to function at guest or user level on your assets. Not quite as bad as root, but not great either. Then you have the denial of service or DOS type vulnerabilities, which are going to allow an attacker to compromise the availability of a particular service on that target host. Things like SYN floods, ping of death, and buffer overflows, good example of denial of service attacks. And finally, you have the type other here, which refers to vulnerabilities where some level of confidentiality or integrity loss occurs without actual access being provided to the system on which the vulnerability lives. That would fit for things like man-in-the-middle of attacks. Those would be part of those other. Switching over to the vulnerabilities tab, this is where you're going to go to get a list of the vulnerabilities that exist in this selected device group, along with some of the details on about them and on the hosts which they exist. It's quite a list, some 1,500 vulnerabilities. You could scroll through them all here. If I wanted to see 100 of them, I could flip over and see 100 at a time. Same trick applies here. For the 100, I could expand this to 1,000 if I added a 0 in the URL. And finally, where we really want to see the benefit here is in this risk map tab. And this is where we're going to be able to actually start to understand what's happening from a vulnerability perspective, where they live in our network, and what hosts we might have are exposing those vulnerabilities, and what we can do about it to block them off. So the risk map is going to show you a map of your network here similar to your device map. However, now we're going to add in these colored sections, as you can see in the middle here. I'll zoom in a little so you can read it better. That's telling us that this middle segment here, 10.0.0, which is /24, has all of the vulnerable devices living on it, and it lives in the middle of these three firewalls right here. So below the risk map here, you'll also see the asset name, which will be showing me the CVE IDs of the vulnerabilities that are present on this particular asset, and which service is going to be used to exploit them. If I click on that, it'll show me that it lives up here. So the real bonus here is being able to simulate an attack from any one of these network segments to understand whether or not there are paths in my network that are vulnerable, allowing me to exploit those vulnerabilities that exist on the assets that are inside this particular segment. So for example, if I wanted to test that from this particular segment to find out how I would access these vulnerabilities, or if I could exploit them, I can right click on that segment and select attack from here. And then FireMon's risk analyzer is going to go ahead and perform a 360-degree attack on that network originating from the segment that I selected here, and it'll detect the vulnerable network segments and display these bold lines on the map that are representing the attack arcs or different paths that can be exploited during an attack between the compromised network segments on the map. So red lines obviously are going to indicate the most vulnerable paths. Orange and yellow lines are going to indicate moderately vulnerable paths, and green lines, if there were any, are telling me that there's a low vulnerability path. And again, that's going to match up with the vulnerability type, you know, the denial of service, the man-in-the-middle type stuff, and the lower, the other type. So those are all going to match up with that color scheme. So red lines, of course, are indicating the most vulnerable. So if you see an arc like this originating and terminating on the same segment, that's just an indicator that there are multiple exploitable hosts that live on that network segment, in this case, all of our network hosts. And that's telling you that you need to patch all of those hosts in order to eliminate those to prevent people from exploiting one and then hopping on to the next. So up here on the top of the All Assets panel, if you scroll down, you'll also be presented with recommendations on what you want to patch in order to deal with some of these vulnerabilities, and you can actually simulate that patching if you wanted to decide which order to do it in. FireMon is recommending that you patch 14 assets within this segment in order to protect the 1,524 assets that live there, which will prevent you from this big red vulnerability. So if you were to actually simulate that patch and then recalculate, you'll see that the most severe attack arcs have disappeared, and you're left with the secondary attack arcs, which you need to patch 8 compromised assets to address, and the related asset value of those assets. And again, if I want to clear that out, I would just go ahead and click that and then click recalculate, and then I would get rid of that yellow attack arc as well. These are all the slides that are very confusing and hard to follow, which is why I just did it through the lab to show you how that works. All right, next up, let's talk about APIs. So APIs, so far we've spent most of our time talking about the graphical user interface and how we can make it work for us. Now we're going to take a peek behind that curtain and look what makes all that possible. So first off, we're going to talk about APIs, or application programming interfaces. We'll learn how you can access them. We'll talk about some of the more commonly used ones for FireMon, and how we can also use SYCL within API queries. And we'll look at how you could use them to integrate with scripts or other applications. So first off, I guess we should define it if you're not familiar with API. API stands for Application Programming Interface. These days, most modern software is built around APIs. APIs are really a set of subroutines, definitions, protocols, and tools which would be used to build a piece of application software. In general, it's going to be a set of clearly defined methods of communication between the various components of a piece of software that you're trying to build. A good API will make it easier to develop a computer program by providing you with all of those building blocks, which would then be put together by a programmer to build a particular application functionality. You have APIs for web-based systems, for operating systems, databases, hardware, software libraries. There's APIs for pretty much everything these days. So what can we use APIs for in FireMon? Well, in the FireMon universe, anything we can do with the graphical user interface is driven by some form of API in the background. So that means that we could do things like troubleshooting or quick automation of simple functions through API calls. We could also get detailed information without having to dig through the database. Perhaps we could do some scripting of repetitive tasks that we always have to take care of. We can use APIs to integrate with other tools, as we just saw a few slides back. That would be Service Manager, ServiceNow, your ticketing type tools you could hook up through API calls back to Policy Planner. Or you could even go so far as building your own homegrown or custom applications, which are going to use the data in Security Manager to drive different applications. Excuse me just a second, I'll grab a drink of water. All right, how do we access the APIs in FireMon? Well, we can do that a couple of different ways. You can get at them through browser calls. You could use third-party tools such as Postman, or we also offer an API reference page in our GUI, in the administration GUI specifically, which takes us to one of those third-party tools that's called Swagger. And this is what the Swagger interface is going to look like. I'll actually show it to you in real time in a few minutes so you can see what it looks like. Now, here we are looking at some of the common and useful APIs here. While we're doing that, it's worth noting again that everything going on in the FireMon GUI is driven by some form of API in the background. So any API that we make available to you is one we're already using to drive our application, which means that anything we do in the GUI, you can probably do via API calls from your own script or some form of integration with another application. So here are some of the APIs that our customers commonly use. The first one here would return all of the information about a specific device in your FireMon ecosystem. The second one here would return an inventory of all the devices in your system. This third one here would output the results of a SQL query to a CSV file via an API call. We could use the API here to export results of traffic flow analysis directly to a spreadsheet if you want to do several iterations of how many flows are being allowed by one of those big any rules. For your compliance teams, for example, this last one here could be used to pull all of the user groups that a particular user is assigned to so you can understand what permissions they have. You could get more complex here on what can be done with APIs with different combinations. We can produce an awful lot of functionality, such as, for example, you could get a list of open policy optimizer tickets. You could use APIs to open new policy planner tickets or assign that ticket to a user in a particular stage. You can use them to update rule documentation. If you're trying to bulk update a large amount of rules, you could do that through API calls as well. You could have them set up to automatically approve or complete tickets in those third-party tools that you might be using. You might also have noticed here that a lot of these tasks are going to be centered around Policy Planner and Policy Optimizer, which is because those modules are going to be the ones most commonly integrated with external systems. All right, any SQL query you run in Policy Optimizer can also be run through an API call. For example, here, this one would allow you to output the results of that query as JSON formatted text for easy importation into some other tool. By using the API, we can take the raw data, stream it directly to another tool as JSON formatted text with all of the results being streamed simultaneously, or perhaps output all of the results in a CSV format instead. A JSON, for those who might not be familiar with it, is open standard Java-based syntax for storing and exchanging data, and it uses humanly readable text, so you can see that you can actually understand what that particular JSON string is actually going to do. All right, primarily customers are going to use APIs to integrate with either scripts that they want to run or applications that they use outside of our FireMon ecosystem. Some examples of simpler ones here in the first tab would be using a single API call to remove stale SSH keys from a device configuration in Security Manager, or perhaps just retrieve the inventory from a data collector. In the medium end of things here, getting a little bit more complex, you could have scripts or programs that make multiple API calls to remove all of the SSH keys from a device configuration, or perhaps use it to fill in Policy Planner form with data from your external ticketing systems. And on the high end of things up here, you can actually put APIs together to form completely custom applications or interfaces to your FireMon ecosystem. We have some customers who have built their completely own GUI for Policy Planner tickets. They have a GUI that sits on a website on their corporate web. Users access that to request change tickets. Policy Planner in the background is contacted by API, runs pre-change assessments, decides which tickets are going to be pre-approved, goes ahead and implements them. And if they're not meeting the criteria for that pre-approval, they actually route them for reapproval and then go through the approval stage and then go through that. So there's a lot you can do to modify exactly how that happens. And in some cases, you can drive it all outside of your FireMon ecosystem you wish. You could have just your external scripts or applications completely use all of the data that FireMon has and those compliance checks to drive the behavior of your other applications. Excuse me. Let me show you how you actually get at those APIs here in FireMon. Actually, you know, I'm going to back up here a second, just one moment. Just to show you how you get at them. That took me directly to it, so I will show you how I reach it as opposed to showing you what it looks like. So you'll start off in the administration panel of your FireMon ecosystem, and you'll go over to the help menu here, and you can see there's an item called API reference. Once you click that, you'll be taken to the page where I just jumped off, which will allow you to enter your GUI credentials, which will then allow you to look at all of the API calls available to you in your FireMon ecosystem. So for the purposes of that, I will just log in again with my credentials, which will allow me to look at them. Once I've entered my credentials, you click Explore, and FireMon is going to populate the list of APIs available to me, starting off with the Security Manager specific API calls. These are going to be organized here in sections. You can see here that you're taken by default to the Security Manager APIs, and they're all arranged in functional sections. So you might want to look, for example, at APIs that are associated with devices that live in your environment. If you just click on that, it'll expand it out and show you the list of API calls available down there. For example, if I wanted to get a list of all the devices that live in my FireMon ecosystem or this lab, I could actually click that one. And this is that Swagger interface. It is a third-party interface that we have provided for you in this GUI just for the simplicity of being able to drive API calls out of here. Excuse me. It was my voice. So generally speaking, this is what you're going to do to drive that API call. You could drive it straight out of here to this third-party interface called Swagger. Little important note here, you will have to enter a domain ID, which is, again, that customer ID. In particular, if you're a managed security services provided licensed, which means you have more than one customer and domain, you have to specify which one of those customer domains you wish to run this API call on. You also can provide, more specifics of what type of device you want to see, and provide some sort parameters to only show you particular fields if you wish, or how, and how many output you want, how many pages you want to output, and how big you'd like those pages to be, as well as any search parameters you want to specify in there to get more details, specifically. So an important note here, the button on the Swagger interface says try it out. Realistically, it's not going to try it, it's going to do it. So not a big deal here, because all I want to do is get an inventory of the devices that live in my ecosystem. More of a big deal if I'm trying to look at a destructive type API here, which would be bulk delete all my devices. If I were to actually put my domain name ID in here and click try it out, I'm not going to try it out. I'm actually going to delete all of my devices, and I'm going to be pretty sad, because it means I'm going to have to go back in, recreate them all, and re-import them in, or restore them from a backup. So just be careful. Try it out actually means do it in the Swagger interface. I've been told that newer versions are changing that. Swagger is not ours to change. However, we've been told that they're going to change the name of that button to actually say, run it or do it, or something more decisive, telling you that you're actually going to do this. But for the purposes of demonstration, I will just run this one. We'll go ahead and click try it out. What you want to expect to see is a 200 response code telling you that you got an actual successful response from that API call. And you can see here that the response body is going to show me that I am now managing 16 total devices with my FireMon ecosystem. The first one has a device ID of 77, a device name of Andy Fortigate belongs in customer domain 1. Here's the description of it. If it has an external ID defined, it's here. There's its management IP address. If it has any management station or parents, it would show up here. If it has children, if it is a management station, it would show up down here. and then so on down the line, what device pack it's using. All the details about this particular device, and all my devices in this case, are going to be provided. And this is the JSON formatted text that we were talking about, the JavaScript notation that is actually quite easily readable by both machine and people, so that you can understand what's going to happen when you pull this information out and run it through something. So again, by default, you will be taken to the Security Manager APIs when you're looking in here. However, there are APIs available for Policy Optimizer, Policy Planner, and Orchestration APIs, which are headless APIs, allow you to do a lot of things without worrying about the application directly. So for example, if I wanted to look at the Policy Planner ones, I would just select those, click Explore, and once again, I will wait for it to populate. And now you'll be shown APIs that exist specific to that Policy Planner application, allowing me to perform API calls specifically to my Policy Planner application for my change tickets for my firewalls. All right. Here we are on the FMOS section. FMOS is, again, our proprietary operating system, the FireMon operating system. And let's get into some of the details on what you can do about that. This is our last module, by the way, so we're hitting the home stretch here. FMOS is our proprietary operating system, and it's based on CentOS. And it is the operating system that runs under all of the components of the security intelligence platform. Notably, the application server, database server, and data collectors are all running on FMOS under the hood. So in this section, we're going to go over what access methods are available for FMOS, how you would go about configuring and monitoring backups in your ecosystem, how you're going to be able to view the various logs within FMOS for troubleshooting purposes when you're running into issues, talking to your devices, and as well as how you'd set up monitoring for device health. All right, as we mentioned earlier, there is no ability to escalate privileges through sudo or access root by design in FMOS. That took place as of version 8.2.3, I believe it was removed. The problem was, people had the ability to escalate privileges, go into the database configuration, and play around. Not all techies are created equal. If you simply added a white space in the wrong place in the database configuration, you could cause catastrophic crashes. The database would fall apart, your entire ecosystem would stop running, and then you would have to rebuild or restore from a backup. Not exactly a pleasant way to do things, so that ability was removed, and we've provided you with some tools to access administrative functions without doing any damage. So you can also SSH into the command line, as you would on most Linux systems, or you can perform various operating system commands via the server control panel, which is a separate graphical user interface that we provide to you in order to be able to access those command line functions. You access the server control panel through your browser over port 55555, and you will use credentials that were set up for command line access, no longer the same credentials that you would use for your GUI access. In that server control panel, you'll be able to do things like change your command line access passwords, schedule and manipulate your system backups. You'll be able to do some disk analysis and cleanup activities, make changes to the network settings on your FireMon servers, also configure email or SMTP settings, as well as Monet for health monitoring of your FireMon ecosystem. You'll be able to configure that out of the server control panel, view some server health statistics for each of your FireMon servers, as well as generate diagnostic packages, which is the packages that we let you set up that compile all of the log data and setting data from your ecosystem. Since you don't have root access and can't get at them, we have this script that runs, collects all those pertinent information, wraps them up in a tarball and encrypts them, and allows you to upload them to our FireMon support organization through our SFTP server, so that our support people can take a look at all your logs and settings to make sure that they can help you with any issues you might be having. So let me log into that server control panel to show you what it looks like. And again, you can see here that I am now logging in through port 555 in my browser. It's the same username at both command line and GUI for me, but it's a different password. So I'll just enter my command line password at this stage to get into the server control panel. And once I'm in, you can see that I am in fact in the control panel. This Training Lab is an all-in-one box, which means my application server, data collector, and database server are all running on one logical platform. If this were a distributed environment where those are separated, you would have a server control panel in existence for each of those device servers. For example, there'd be a server control panel for your data collector, a server control panel for your database server, and a server control panel for your application server that would each have different settings, as opposed to everything wrapped into one here. If I show you here, you can see that I have all of the settings for database, application server, and data collector in one, since this is an all-in-one. So right at the top here, you're going to see that we are in fact in the server control panel, and there are some health checks that are going to be run here for the system right out the bat, and you can see that I've passed all 29 of them. If I want more details on what those health checks are, I can click full health check and be given the details of what all those health checks are that have been run against my servers and their status. Everything is green in my training environment. If there was anything not green, there would also be a link stuck next to it that would take you to that knowledge base and show you an article on what the health check is trying to tell you, and the steps will be provided for you to go ahead and address that health check and make sure that it goes away. There are also some KPIs here in the server control panel showing you varied load averages for the server that you're running on, as well as a graph for memory utilization. And if you're using any swap, it would be shown here how much swap you're using for your memory. Swap generally meaning that you are paging out the disk as opposed to using memory, which generally is going to tell you that you are running out of RAM and probably need to update pretty soon. All right, the next tab over here basically is going to allow me to change my password, and this is whatever user ID I have logged in with. This will be asking for my current password that I just used to connect, and then if I want to change my password, I would do so up here by entering a new password twice. Shifting over the next tab here, this is going to allow you to look at your disks on your FireMon servers. Again, this is an all-in-one, so I'll be looking at everything. Or if it was a separate one, you'd be looking at the disks for each one of your FireMon application servers, data collector servers, or database servers. So I can decide which type of files I would like to analyze. The first step is going to run a disk analysis to tell me if there's anything sitting around on my disk that I could get rid of and regain some space. I'll make it a nice short time frame since this thing gets cleaned out fairly often. I want to see files that are older than 1 day. So FireMon's going to now do a disk analysis and tell me that there are, in fact, some old files here sitting around on my disk that I might want to get rid of to reclaim some of this space. Not an awful lot, but at least I could get back, you can see here, got about 200 some odd meg, 225, 230 meg of space that I could reclaim because there's some crashed application memory dumps, some old log files, and some old device pack temp files sitting around as well. If I wanted to clean those out, pretty simple. I just select the files that I want to get rid of, and I will reclaim that disk space as soon as I click the next button, and then you will be able to see that FireMon will actually go ahead, clean that out, and tell me how much space I've gotten back by doing a disk cleanup. Switching over to the next tab, you have the Diagnostic Packages tab. This can also be done at the command line with a little bit different command configuration, and I'll show you that later. But if you want to do it from your server control panel, essentially if you are submitting a support ticket, our support engineers will typically ask you to submit them a diagnostic package, which will take all of the logs from your FireMon servers and wrap them up into a lovely tarball, encrypt that. The support person will also give you a ticket number, which will be used to create a directory on that SFTP server that we have publicly. You will specify that ticket number as an argument here. Right now, there are 6 digits. They might get longer over the years, but right now, they're only a 6-digit number. And once you specify the ticket number that they provided you that is your support case, you go ahead and click create. And then create essentially will cause FireMon to start collecting all of the log files and all the settings that are relevant to be able to help you troubleshoot any issue you might be having. It'll wrap them up into a tarball, encrypt that tarball, and then it'll do it with our public key, which will allow you to safely upload all of the details to our publicly available SFTP server, which will then be pulled down by one of our support individuals, and then they'll be able to actually look at the logs and everything else from your ecosystem to understand what might be going on if you're having difficulty getting something done. This might take a little while since it's going to collect all of our logs and all of our interesting data, so we'll just move on from this one for the purposes of time. But essentially what it would do is create one of these tarball packages, which you would then SFTP up to our publicly available server. Looking down on the OS tab here of the server control panel, this is where you're going to be able to make a lot of the configuration changes to the actual operating system itself. Again, this is how we allow you to make these kind of changes without having the ability to escalate privileges or access root. We can make changes here to a lot of the console timeout, like how often you get to enter a password before you get locked out of the console, how long that timeout is going to take before it's released. There's settings here for what the host is that's going to be sending your alerts when it finds things, which email address it's going to send any Monet notifications to, Monet being the system which is going to monitor, the back end to tell you that there's something that's going on that you might want to pay attention to. And these are the various thresholds that you can set at which point you want to see those Monet alerts showing up in your mailbox. You can change them. However, you probably want to be careful with changing them. You have to give yourself enough time to respond to those alerts. If in particular, for example, if at 30% of disk left you start, or 30% swap, it's going to start telling you you have some swapping going on. You could increase or decrease that, but you might not give yourself enough time to increase your RAM in the event that your disks start filling up or you're doing a lot of swapping. You might need to act fast, so you probably want to leave these at default and not run the risk of coming in too late. Down here on the authentication tab, this is where you will be able to configure authentication tab for command line access as opposed to GUI access. You have the option of using either Kerberos or LDAP as offboard authentication if you don't wish to create authentication from a GUI perspective or from the command line perspective via hardcore defined passwords in your FireMon ecosystem. Also, if you have compliance standards that you need to meet, in particular, I know PCI, you have to have a particular password policy for anything that's in scope of your PCI audit, which your FireMon data collector would be, since it talks to your firewalls that delimit your PCI zones. So you would have to come in here and make sure that this password policy is compliant with your PCI requirements for people to be able to get at your data collector. All right, next, the page there on the OS level is the backup settings. And this is where you're going to generally come in here to modify or update the settings for your backups. Again, whenever you see anything in blue here, mouse over to get information on what it is you're going to be shown. Generally, the arguments for the backup are going to be which directory it gets stored in. By default, backup files get stored in var_lib backup FireMon. You could change that just by simply specifying a different directory here. There's also some backup scripts that will run post-backup, which will take your backup file off your FireMon servers and SFTP them or SCP them onto another device in your network. Highly recommend that you leverage those. You will find the information on how to do so in your Getting Started guide. If you think about it a little further, your backups will be stored on your FireMon servers. If your FireMon servers crash and the backups for your FireMon servers are on the FireMon server that crashed, well, you're out of luck because you've got no file to be able to restore your FireMon server to where you were before it crashed. So highly recommended that you leverage those scripts in order to move those backup files out of your FireMon ecosystem and allow you the ability to restore it should something go bad. Also of note here, you can change the date when your backup takes place. You can change the time. By default, it's going to run daily at midnight. If you wish to change that, by all means, you can come in here and make changes to when your backups run. Of note, backups are not incremental. They will be full backups every time. which is another reason to have that script enabled to move those backups off your FireMon servers. I've seen quite a few client environments where backups reach into the 10, 20 gig area. If every time your backup runs every day, it drops a 20 gig file on your disk, it won't take too long before your disk fills up. And as you know, full disk on a Linux server is never a good thing. Bad things start to happen. So make sure you leverage those backup scripts to get them off there. All right, we also have some health statistics or health settings that you can modify here, which will change the thresholds on how much swap space is going to start alerting you, what the data collector degraded threshold is, and various other settings that will control just how many Mon alerts you get telling you that there might be a system issue. Generally speaking, again, you don't want to change those unless you are doing so under the guidance of a support ticket with one of our support engineers. You also have the ability here under the OS Network tab to make changes to the network settings of your FireMon servers. Your application server, data collector, and application servers will all have interfaces and IP addresses just like any other Linux box. If you have a DNS server that you need to reference, you can configure it in here. There's your interface configurations for this particular server and other things like routes that you can add, netmask and so on. If you're using network time protocol, which is highly recommended, you want to make sure that all your FireMon ecosystems, in particular in distributed models, are synced up from a time perspective. So highly recommend that you set up your NTP servers here to get a common time setting for your FireMon ecosystem. You can use DHCP by default, which will just pull that time up, or you can set up your NTP servers if you got them, and any keys you can enter here as well. For that to be able to work and for your FireMon servers to be able to pull that time setting from NTP. If you're using a proxy, you might need to configure a proxy to access the internet for FireMon to be able to get out to the internet. If you wanted to be able to call home, check for latest versions of FMOS, or do other things like that, you would provide it a path to get to the internet through your proxy in this particular tab. If you're going to be sending emails out of your FireMon ecosystem, which is probably the case, most people do, if you need to have authentication set up for your mail server, you can do that here, or if it's a relay host, you can specify which host it is and what port it runs over, and as well set up your password or your authentication to get at that relay host and allow FireMon to be able to go ahead and send email through your corporate mail servers. This is version 9.23, which still has SNMP capabilities. This has been deprecated as of version 9.3. This is still using SNMP v2, which is no longer compliant with many compliance standards. So at the moment, it's been replaced with another monitoring system. I'm not sure whether when v3 gets implemented in, we'll put it back. I would assume so, but this will be gone in version 9.4 and up. There will no longer be the ability to set up, community strings and have your HP OpenView host or Tivoli host go ahead and poll your FireMon servers. The SNMP traps that would come out of them anyway are simply OS level traps from your CentOS traps, such as disk and memory utilization, which you're already getting from your Mon alerting anyway. Here in the SSH tab, you can pretty much only do one thing, which is allow weak SSH algorithms from your clients. For example, if you have super old Cisco firewalls still in your environment, newer versions of FireMon are using updated algorithms or updated ciphers, which are now compliant with most standards. If you have some legacy devices that can't make use of those in your environment, you still want to bring them in and manage them with your FireMon ecosystem, you can enable that here. You would also have to go into the device configuration and enable that, allow SSH weak ciphers to be used in your SSH keys. If you are going to want to forward syslog to any external server from your FireMon devices, such as a Splunk server or any kind of SIM that you might be running, you can set that up here on the syslog page and do a remote syslog server configuration, provide the IP address or host name of your Splunk server or ArcSight or whatever it is you're using. You can also set it up to use TLS for compliance purposes as well. Just keep in mind that whatever it is that you're going to forward here is anything we log. So if we're logging it, then it'll forward through that syslog connection. That means our data collector log files, application messages, operating system messages, all of it's going to be sent to that syslog server. Be aware that that can generate a fair amount of traffic. Now, one of the things you might have noticed here down at the bottom is that there's now 2 buttons. So the reason for that is you are now making configuration changes to the database. So for example, your data collector logs here will start off in informational mode, which will provide high-level information, but not nitty-gritty, down to the absolute detail that you would get in the debug mode. So if you want to turn on debug mode to get a lot more information, for example, if you're troubleshooting some sort of issue with retrieval between your data collector and devices, you could turn your data collector root log level down to debug level, which would give you extremely granular information on what's going on between your data collector and the devices trying to talk to you. Once you want to do that, after you enabled that toggle, you would do stage changes. Basically, once you click stage changes, you've locked other users out of the database so that you can't have 2 users trying to change the same database field simultaneously, which could cause corruption. And again, corrupt database field, bad things happen. So I've now locked other users out. And as soon as I click apply configuration and click submit, FireMon will go ahead and turn my data collector log level into debug. And then the stage changes button is going to get released, allowing another user to come in and make changes behind me, or in this case, allowing me to go back in and turn the data collector root log level back down to informational level, because if I leave it at debug, it's going to get awfully busy and the log is going to start rolling really fast. Similar to if any of you are Cisco experienced, you turn your Cisco firewall onto debug mode, get a lot of great information, but if you leave it in debug mode and walk away, your logs start rolling really fast and your disk starts filling up really fast. Same thing here. As soon as that closes, I will go and put it back in debug mode or back in informational mode, which is highly recommended if you are going to be doing that in your particular environment. All right, I'm just going to close it for now so we can go ahead and move on with the rest of the class. Okay, so finally, we have in this SecMGR tab here, you have the ability to make changes to your application server, the Apache server that's running on it. You can change the log settings here, as well as the maximum log size that's going to be reached before those logs roll over, which will then append a log-1, log-2, log-3 on top of the SecMGR log that you might want to look at. We'll get into the specific logs that you can and cannot look at in just a few minutes. You can also modify settings for the ndexec.log, which is the log that contains information about that normalization process when you pull in the raw configuration files, and the SecMGR process as well, and workflow log, which will contain logging information about your policy planner or policy optimizer tickets. If you're having any issues getting those to work the way you think they should work, you go and check those logs. You also have settings for the database itself that you can set up here. The number of standby servers, you can have it as a standby database running in the background, along with a few other particular settings. And the same thing for your data collectors. This is where you would go to turn that data collector root log level back into informational, which I will do right now, since I have the ability to. And I'll apply configuration, and that'll happen while we go on. All right, and finally, you have the Elasticsearch level here, where there were configurations before, but again, those were making changes directly in the database, and those have now been moved to a specific level of control panel, which is configured to allow those particular operations since you're playing around in the database, and those can now only be accessed through an API call that opens up that advanced control panel, allowing you to make those changes, preferably under the guidance of a support engineer, so we make sure we don't break anything. All right, a few details on backups and restores. As we just saw, you can configure them and schedule them from your server control panel. You can also schedule those backups, or actually not schedule them, but run them manually from the command line itself after you've connected to whichever server it is you wish to back up via SSH. And also you can restore a backup in that manner just by dropping the backup file in the var lib backup FireMon directory, and then doing an fmos restore command, and we'll look at that in a second here, which would then restore your server to the status in which it was when the backup was taken. All right, here are going to be some of the more commonly used fmos commands, fmos being, again, your FireMon operating system. These you can run at command line. For example, fmos backup is going to launch a backup of whatever software that you are sitting on. If you're sitting on the data collector, it'll back up your data collector. Enable updates is going to allow you to actually pull out internet updates from versions 8.2.6 and above. Your server will be allowed to call home, and if it finds a newer version of fmos, it'll pull it down and tell you that there's one waiting for you. It won't actually deploy it, but it'll pull it down for you automatically. fmos hardware is going to show you basic hardware information about the device that you're sitting on. Log view is one of those commands that will allow you to look at the inside contents of some of your FireMon logs, and we'll be diving into that in a little bit more detail shortly. There's that mcdiag package command that you could run from the command line as opposed to running it through the server control panel. Once you get logged into your server via SSH, if you want to get a diagnostic package, you would just type the fmos space mcdiag package, and then use an argument of the ticket number that you will have. And then you also would have the optional switch of -u, which would upload it automatically to our SFTP server under the guise of that trouble ticket using the password that would be sent to you from our support engineer. And you have various other commands here. Redeploy will reapply the FireMon system configuration. Restart will restart all the FireMon services. fmos restore is the inverse of fmos backup. This will restore your server from a backup file. fmos status will show you how your FireMon services are doing. If you do have enable updates and it pulls down a new fmos version, fmos update will actually trigger that installation and update your system to the latest version of fmos from the file that you have in your var temp directory. And fmos version will tell you what the version of your installed FireMon software is. All right, let's just jump into that training server here quickly at command line and show you what some of those commands look like. So if you're not familiar with fmos and you've logged into your server at command line, which I am now at here, first off, just do an fmos -h, and you will get to get a list of all of the commands that are available to you. As the user that's logged in, they will change according to permissions that are granted at user level. There are some of those commands that are available to us. You can see here, backup would allow you to perform a backup. CA is going to manage the certificate authorities, which are typically the database. It can also be an external CA if your particular corporation has their own CA to sign certificates, keeping in mind that all of the communication between your FireMon modules is going to be encrypted. Therefore, you need some sort of certificate for that to happen. fmos config is now gone. That's been replaced by that advanced control panel that you can access through API calls. There's that fmos disk cleanup, similar to the same one that we just ran out of the server control panel. If I did fmos disk cleanup, it would go ahead and look at the log files and everything else to see if there's any files sitting around on my server that I can reclaim some disk space from. fmos ecosystem will allow me to perform configuration commands on the actual ecosystem. Things like ecosystem refresh would cause my data collector and application servers to go and refresh their server certificates from the CA, which would be the database, and redeploy that new configuration. Factory reset is an interesting one, which will actually restore your FireMon server that you're logged into to the status it was in immediately after having been installed. So it's basically wiping everything out. Any new configurations are gone, and it's back to vanilla configuration waiting for you to configure it. So that's a pretty brutal one, but can also be handy if you're trying to do something, start from scratch. And then you have various commands here that we won't go through all the way, but they're available to you just by typing fmos -h to find out what they are. And also important here is the fmos user list privileges command, which will tell you which permissions the user you are logged in with owns. So that's going to tell you what you have as far as permissions goes from the command line. If I have fmos admin permissions or fmadmin permissions, that means I'm allowed to run fmos commands and I can administer the system. If I did not have administrator privileges, I would not even be able to type a single fmos command. I would simply get a permissions required. fmos backup or fm backup key is going to allow the user who owns it to manipulate backup files and the backup directories for the purposes of moving those backups off with that script. You need to have FM backup permissions in order to be able to do that. And finally, there's the Wireshark key, which will allow the user who owns that the ability to actually run packet captures using T-Shark or Wireshark, so you can capture packets at interface level on your FireMon server if you want to look at some really detailed communication to see what's going on if you're trying to troubleshoot a particular issue. All right, if you are the lucky administrator of your FireMon ecosystem, this fmos log view command here will allow you to view the actual logs that are in your FireMon ecosystem. This is going to become your bread and butter for doing troubleshooting required to resolve various issues you might be running into. The most typical being connectivity between your data collectors and devices during either the retrieval or normalization process. So this fmos log view command is going to let you view the contents of those various system logs. You could view var log messages, which exist on all Linux boxes, as well as any FireMon specific logs. And again, this is how we provide you the ability to look inside those logs without escalating through sudo or root privileges. So these are the log files that you're most likely going to be exploring most often in your troubleshooting adventures. The secmgr log here is going to contain all the logs pertinent to activity on your application servers. The secmgr metrics.log will have a record of application server activity that is slowly responding. So if you are having application servers bogging down, go check that secmgr metrics.log file to see why it might be going slow. The ndexec.log file will contain information specific to normalization process, which again is the process when that raw device configuration is retrieved and then massaged into that vendor agnostic view that you get to see in your GUI. The workflow log or wf.log is going to contain metrics that are going to show you data related to workflow applications, i.e. policy planner, policy optimizer. So if your policy planner workflows aren't delivering the kind of functionality that you are expecting them to, you would want to go look in the workflow log to find out what's going on at that level. You also have, which I apparently skipped, this data collector.log file is going to contain a higher level activity that's going to be related to those retrieval processes between your devices and your data collectors when your data collectors try to reach out to your device to pull in all of the configurations. The logs for that are going to show up here in your data collector.log file. And finally, you have this last one down at the bottom here, which is the devpack.log. So that one's going to allow you to examine those retrieval related information specific to one device IP address that you'll specify. So you'll actually go inside the var log FireMon DC directory, and then you'll find other directories in there that are going to be listed by IP address, and they will be the IP addresses of the devices that you're managing through your FireMon ecosystem. And if you actually do an fmos log view specific to that IP address of its devpack.log, then you're going to get much more granular level information, almost debug level information from your data collector specific to that one device, which will allow you to get more granular in your troubleshooting and understand at a lower level for those purposes what's going on between your data collector and the devices that you're trying to actually manage. All right, let me show you some of that in real time so you can see how you would go about looking at those logs. So starting off, one of the first things we want to look at maybe is that secmgr log, which is going to show us log information relative to our application server, which is going to show us the logs for all of the activity going on to create the various views in Security Manager to allow you to see your devices in that vendor agnostic form and the dashboards and all that. You'll see that actually happen in the secmgr.log file. So if I wanted to see that, I would issue the command fmos log view. You'll notice that the switches I'm using here, which is minus uppercase T, lowercase f, is a tail follow command, which is basically going to allow me only to look at active data in the log. I could just remove the TF and see the entire var log, secmgr.log, if I want to go back in history. But for now, I just want to show you what's actually happening in the log. So I'll use the tail follow command to show you what's actively there. Once I go ahead and click enter, you'll see that there's a little bit of information that's going to come, which is just going to show me a few details, but there's not a lot going on here because it's quiet. So if I actually try and view a device in Security Manager, for example, here, I'll open it up and log in again. And I will now be shown the API calls running in the background to show me the actual configuration here that this dashboard is showing me about my Palo Alto firewall. So these are all the API calls running in the background that are actually creating this view. And that's what I get to see in the secmgr.log. So if you're ever having issues getting the view that you think you should be getting, go take a look in there to find out what's going on at your application server level. All right, generally, the most commonly viewed logs are going to be the data collector.logs and the devpack.logs. So when you're having issues trying to retrieve data from one of your particular devices, and for some reason you're not being able to load its configuration, the first place to look is going to be the data collector.log file, which is going to give you some high-level information on the process of your data collectors trying to connect to your devices and load their configuration. And again, I'll use that tail follow switch to only see live information. And you can see here that it's going to be pretty quiet because there's not a lot going on in this trailing environment. However, if I come up to my devices here and actually launch a manual retrieval on a device, you will see that retrieval kick in here in the data collector.log file. And as soon as I do that, you should see that start to troll through. There you go. You can see that I've opened up the device pack for that particular device, and that I'm now downloading the configuration for this Cisco firewall. And you can see that I'm now retrieving from it, and that I've collected its configuration, how many policies I've picked up. And as soon as it terminates, it'll tell me that it is done collecting the configuration of that device, and it'll show me the little pop-up window here that says that I have actually gotten the device change there picked up. So if I wasn't getting the kind of information that I expected to see from that, and I wanted to see more detail, that's where I'd go down to that devpack.log level, which will give you much more granular information about the process going on between your data collectors and your devices. So again, I will choose that fmos log view command, and again with the tail follow, so that I can see only the active stuff going on in the log. And now you can see that I've given it an IP address to look at, which is going to be the directory that is going to contain the devicepack.log for that specific device. And if I go back and look here in my device manager, you can see that this Cisco ASA has a management IP of 10.0.0.7, and that is exactly what I've specified here. I am now looking in the logs for that particular device specific to the device pack retrieval. And now if I launch that same retrieval, you'll see that I'll get much more detailed information about that retrieval process, and you'll see it actually kick off here. Oh, you'll see it kick off if I actually hit enter. There you go. Let me redo it again so you can actually see that take place. There you go. So now you'll actually see the device pack being opened up. You will see the commands that it's actually executing as opposed to the higher level stuff. Each one of those particular configurations being pulled down. And then you can see here that I've added a hash for my checksum, and my retrieval is complete. And I've completely collected the configuration of this Cisco firewall, so I can see at that level what's happening between my data collector and the device I'm trying to collect the configuration of. So that is how you go about looking inside the log files without escalating to root or having sudo or anything like that. If you need to get updates, as in patches, those updates will come through new releases. And if you want to update your FMOS, you could do that by downloading whatever files from our user center, depending on what kind of device you're trying to update. If it's a virtual machine, you might be pulling down an OVA file, ISO file to install from scratch, or GPG file for update purposes. Has a versions 8.2.6 and up, which is our first generation 3. After 8.2.6 comes 9.0. The images are immutable. You will simply copy them to your disk, typically in the /var/temp directory on your FireMon ecosystem. And then when you issue the FMOS update command, that new version of FMOS will install itself on that particular server. All right, there are some commands that can only be run at the command line, and there are some server control panels that can only work there as well. For instance, the log viewing, which we were just doing, cannot happen in a server control panel, only can be done in the command line as we just did. The FMOS restart commands can only happen also at the command line. FMOS health can be run at the command line, but you can also get that information out of the control panel. There is a command called IP address, which only works at command line as well, which will just show you the IP configuration of the server that you're currently logged into. If you're looking to check for network connectivity, again, you can run Wireshark to capture packets at interface level if you have that Wireshark permission for the user ID with which you're logged into. And finally, you can also create diagnostic packages from the command line as well as server control panel with the FMOS McDiag package command specifying the support ticket as an argument. A little side note there, if you're trying to run a diagnostic package from the command line, you need to be in the /temp or /var/temp directory in order to run that command. If you try and do an FMOS McDiag package and you get permission denied, switch to one of those directories and you'll find that you will be able to run that diagnostic package. All right, well, that is taking us to the end of our class today and the end of this module. As always, if you have any questions related to the material we went over today, please feel free to email me. I am at mark.rich@firemon.com, and I'd be happy to provide you with answers to any questions you might have as a result of this particular session. I hope you all have a great day. Thank you for joining me today, and I hope to talk to you soon. Enjoy the rest of your afternoon and have a great weekend since we're coming up on that soon.